So let me say it again. So just confirm me once if I'm clearly audible and visible right now or not. Hello Ashish. Hello Shreyanshi. Hello Ananya. Hello Ashwani. How is everyone? Yeah, now okay, clear. All right, so what are we going to do today? We are going to discuss 150 questions of this particular physics, right? And the way we are the way we have chosen those questions is we have looked at the patterns that NEET repeats every year or so, and based on the pattern on which the NEET asks questions, we have picked some really good questions that we're going to discuss today, right? And how are we going to attempt it? I will show you the question first. I'll give you 4 options for each question. I'll give you some time to you so that you can attempt it. 30, 40 seconds, 50 seconds. Then I'll give you a hint. And then I will start explaining you the things behind the question, right? So gradually, if you just pick up your pen and paper, right, start solving these questions with me. Now, the notes I have prepared are very special. I have invested so many hours, like literally 10 to 15 hours, just preparing these notes, just making these notes for you, right? And why I have invested so much time in it? I have tried to give you a comprehensive notes for everything. For example, if I'm going to teach you the first chapter, units and measurement, so the basic concepts of that chapter are written, and then I have written the questions for you, right? So if you download the notes, right, you will be able to revise the chapter, right, through the short notes of the chapter, and after that you can look at the questions itself, right? So all of that you can get in the notes itself. All right. So if you guys are ready, just give me a quick yes. We will start right away with the class itself, right? Okay. All right. Shall we? Hello Nitish. Hello Ashok. All right. So let's start right away with the class itself, right? Okay. So here we have it. Okay. Let's have a discussion about few things over here. So let's have a look at that. Right. So these are the topics that we're going to cover today. So you see that we have list of topics, right? So a lot of topics we are going to cover today in this class. Grade 11 topics are there and grade 12 topics are there as well, right? And after that, we will, cover it up. So let's have a look at the first question itself, right? And the first question will come from the chapter of units and measurement, right? Units and measurement. So here you see that for the chapter of units and measurement, I have written some basic concepts like what are the basic symbols of the quantities and what is the dimensional formula of the basic quantities, right? So those things I have done, and based on that we can solve few questions, right? So have a look at the first question. I'll give you the options and you just try to answer it. The dimensional formula for angular impulses. I have taken a slightly better unit. In your NEET exam, they ask you generally, simpler units as well, right? So try to answer it. The dimensional formula for angular impulse, and here is the poll for you, right? You can answer in the chat box of this YouTube itself, right? And it will pick it from there itself, right? Okay. So it's a single option question. So now you should have the options. Just yeah, hello Bideshwar, right? Try to answer it, right? Okay. Zoro is saying D. Shreyansh is saying D. Very good. Okay, try to answer it in the poll itself, right? And the poll will pick it from here itself, right? Okay. All right, so time is up now, right? And let us see how many kids are giving the correct answer, right? Okay. All right. So now let's move ahead and look for the correct solutions. Just give me a second. All right. Okay. So yeah, right. So let's see that. Let's see how to solve it. Okay. So for this particular question, we have to find the angular impulse, right? So what is angular impulse, right? To be able to find the angular impulse, you need a torque, right? You know that. First of all, you need a torque as well as you need some time as well. So here it is, right? You need to find that formula for the torque. First of all, so torque is going to be force into distance. For the dimensional formula for force is mLt minus 2, and for the distances it is L. So mL2 t minus 2, it is the dimensional formula for torque. Once you know the dimensional formula for torque, angular impulse will be the multiplication of dimensional formula for torque and the time itself, right? So just multiply that. So it will become mL2 t minus 1, right? mL2 t minus 1, which becomes the option C, right? mL2 t minus. My dear kids, some kids might be answering what is the dimensional formula for angular momentum. My dear kids, we are not asking the dimensional formula for angular momentum. They are asking the dimensional formula of angular impulse, right? You know the impulse itself. It is force F into dt, right? Force into time. Similarly, in place of force, if you use torque, so torque into dt, that will become the angular impulse, right? Okay. So very good question, right? And very interesting question itself, right? Now, in one question, you get to learn something, right? So if you just keep learning from each and every question, you will find that by the end of the class, you have collected a really good set of questions itself, right? So let's look at the second question now. Look at this one. In the equation, this x is pressure, y is volume. X is pressure and y is volume, okay? R is the universal gas constant, my dear kids, okay? And T is the temperature, okay? The physical quantity equivalent ratio of A upon B. So if you want to find the ratio of A is to B, the dimensional formula of that should represent one of these physical quantity. So which of those physical quantity will be represented by this ratio? Right, try to answer it. And in the NEET exam, this kind of concept is asked many times. However, they ask you much simpler version of this as well, right? So with this question, I will also explain you another concept. So you see that every question is here to tell you something unique, right? So try to solve it. And again, I'm going to give you a poll for this one as well. So here is the poll for you. Try to answer it. You have 30 seconds to answer, right? And after every single question, there will be a poll and you can answer it. Okay. Right. All right. So you see that. Meanwhile, I can tell you some hints as well. So when you are using an equation and there are two quantities, they are separated by a positive sign. That means they have the same dimensional formula, right? Principle of homogeneity is coming into the picture. They have the same dimensional formula, and similarly in these two, they are being subtracted. So they should have the same dimensional formula as well, right? Yeah. Of course, you can complete physics by one shots only, right? So I'll be uploading more one shots and upcoming parts as well, right? So that's just look into that, right? Just look into that. So if you look at these two things, they are separated by a positive sign. They should have the same dimensional formula, and these two things have shared the same dimensional formula. Y is volume. So if Y is volume, B should have the same dimensional formula of volume, है ना? And if X is pressure, so this quantity which is added to X should have the same dimensional formula of pressure, right? If you just apply it and try to solve it, you see that some kids are giving the right answer, and let's see. Aquarius, Monisha is giving the correct answer, Shreyanshi is giving the correct answer, Ashok is giving the correct answer, Ananya is giving the correct answer. Very nice, right? So let's look at that. Right, let's look at that. So here you see it is representing that, right? So it's representing that. So let's have a look at that. So how to find it? So you see clearly, you can say the quantities which are added or subtracted, they should have the same dimensional formula, right? And if I just follow that logic, so A upon Y square should have the same dimensional formula of X. X is, my dear kids, pressure. So the dimensional formula of A upon Y square is dimension of pressure. What is dimensional formula of pressure? Pressure is force upon area. Force has dimensional formula mLT minus 2, and area is L2. So ml minus 1T minus 2, which is this, right? So the dimensional formula of this quantity is same as dimensional formula of X, which is this, right? And Y is volume. So dimensional formula of B and Y should be same. It is L cube. Volume has a dimensional formula of L cube. So this and this should have same dimensional formula, right? So you see that you know the dimensional formula of A now, right? From here you can get the dimensional formula of A, and you also know the dimensional formula of B, right? So from here you can easily get A upon B and you can tell the what will be the ratio ml2t minus 2. ml2t minus 2 is the dimensional formula of energy, you know, right? ml2t minus 2 is the dimensional formula of energy. Aksha Moksh. Okay. So from here you can easily calculate that, right? So I believe the idea is very, very clear, right? Now the next concept is the concept of significant figure. You have to look at the question and tell what will be the number of significant figure in the question, right? Now look at that. Here is the question for you, right? Try to find the number of significant figure in this one. Try to find the number of significant figure in this one. Have a look into this situation. Try to find the number of significant figure in this one. Right? Okay. try to find the number of significant figures in this one. So we can say that the number of significant figures depends on these things. Here you see between 1 and 1 you have these two 0. These two 0 will be significant, right? So clearly you can say that in this one we have 4 significant figures, right? Very good. Shreyanshi is saying A. Nice. Ashmita is saying A. Zoro is saying A. Okay. Another kid, Ananya is saying A. Kanarva is saying A. Chalo. So let's see that. So this one has 4. This one has, now this 0 will not be significant. It is coming before that. So these 3 things will be significant now. So here you have 3 significant figures. Here you see that all zeros will be significant, decimals coming after that, and here the number before the decimal place are significant itself. So clearly you see that all the numbers are going to be significant here. So this one will be correct, right? And here you see that before decimal you have a number 0, right? So any 0 before that is not significant itself. Only these parts are significant. So here you have 5 significant figures, right? So which option corresponds to this one, right? Which option corresponds to this one? A matches with 2, B matches with 1, okay, C matches with 4, and D matches with 3. So option A is correct. Option A is correct. Very nice. So all the kids giving option A are correct. Shreyanshi. So yeah, this particular question, a question session is there for giving you a pattern, right? 150 patterns you will get, right? So in one session you will get a very decent practice for the physics itself, right? So here it is, Shreyanshi. Let's move on and talk about the next one. Look at that. So for the kinematics, right? So from the kinematics we are going to revise very quickly. Let's have a look at some questions of kinematics as well. Right, look at this thing. So there are some basic formulas I have written. You can download the notes and get that. Look at this question and try to solve it. A vehicle is traveling 4 km with a speed of 3 km per hour. Okay. So a vehicle is traveling 4 km with this speed and another 4 km with this speed. Then the average speed of the vehicle is very popular format. Shreyanshi, very popular format. Monisha, right? Very popular format, right? This is a very popular format. They ask you multiple times from the kinematics, right? In the NEET paper, you will find that this kind of questions are there. They are asked multiple times, right? So a vehicle travels 4 km with a speed of 3 and another 4 km with a speed of 5. What will be the average speed? Try to answer it, right? Try to answer it. Okay. You have your 30 seconds now. Okay. Try to answer it. Very simple question. Very nice. Kids are trying. Nice. Okay. So the concept of average speed should come into the picture. What is average speed? Total distance upon total time. Total distance upon total time. Right? You just have to apply the basic idea and the whole thing will be very, very clear. Very nice. All right. So let's see how many kids are giving the correct option, right? Okay. So yeah, all the kids are giving the correct option. 100% result is there. And now we can see that Shreyanshi has given the fastest answer, then Kananva, and then Sonu. Very nice, right? So keep on trying, right? And you can also get your name in the leaderboard. So here you have it. So the idea is very simple. Average speed is total distance upon total time, right? Average speed is total distance upon total time, right? Total distance is, you see that in one part of the journey they travel 4, another 4, so total distance is 8. Total time is, in the first part of the journey, you see that it travels 4 km with a speed of 3. So from here to here, it travels with a speed of 3 km per hour. Okay. So how far it travels? 4 km. Then again it travels 4 km with a speed of 5 km per hour, right? So how much time will be taken in the first part? Time will be distance upon speed. So it is 4 by 3. That many hours are taken in the first part. And you know, time in the second part will be 4 upon 5 hour. That much time is taken in this part, right? So total distance is 4 plus 4, right? And total time is 4 by 3 plus 4 by 5. So just divide it. Total distance upon total time. That is the answer. I believe that is very, very clear. Let's move on to the next part. It is the instantaneous speed and instantaneous velocity concept, right? You know the concept itself, right? Now let us move on and look at the question on this concept. Now look at this question. It's a very good question, my dear kids. Very, very good question. Now it's slightly better question, Sonu. Let's see that how many kids make up to the leaderboard this time, right? So here we have it, right? So it's a single option question. So let's take 45 seconds this time, right? Because this question will take some time. 45 seconds you can take and try to solve it. Okay. So you have a particle that is moving in a straight line. Okay. And the value of x is changing by this equation. The value of x is changing by this equation, right? Okay. The velocity of the body when the acceleration becomes 0. So what is the relation? The concept is very, very simple. You know the value of x, that is displacement with time, right? You differentiate it dx by dt, that gives you velocity, and you differentiate it further d2x by dt2 or dv by dt, whatever velocity you get, you further differentiate it, you get acceleration, right? So you want to answer the velocity at which, velocity when the acceleration is 0. So first of all, get the equation of acceleration, put the acceleration 0, you get a value of time, right? At that time, get the value of velocity, right? Try to find it. Very nice. Kana is giving the answer, Monisha is giving the answer, Rashmita is giving the answer, Divya is giving the answer, Surya is also giving the answer. Let's see that who has given the correct answer, and then I will show you the way to solve this one as well, right? Then I'll show you the way to solve this one as well, right? So without any further delay, let's see. So here you see that only few kids have given the correct answer, and who is that? Monisha has given the correct answer, right? Monisha has solved the question correctly. Let's look at that, how to solve it. First of all, you have to answer the velocity when the acceleration is 0. First of all, they are giving you the displacement. How will you get the velocity from here? Differentiate it. So once you differentiate it, my dear kids, you will get dx by dt. That is the velocity, right? And you see that so many concepts will be revised from this part. So just revise this: 3t square minus 12t plus 20, right? But you have to tell the velocity at what value of time? You have to tell the velocity when the acceleration becomes 0. So first of all, get the acceleration, differentiate the velocity further. You differentiate velocity, you get acceleration, right? So differentiate velocity. So acceleration is dv by dt, right? This is whatever expression of velocity you have, differentiate it. So it is 6t minus 12, right? This is the acceleration. Now, when will the acceleration be 0? Acceleration is 0. That means this part is 0. 6t minus 12, that is 6t is equals to 12. That means at t equals to 2 seconds, acceleration is 0, right? And now you need to tell the velocity when the acceleration is 0. At t equals to 0, acceleration, at t is equals to 2 seconds, acceleration was 0. Put that over here, right? So velocity at t is equals to 2 is going to be 3 into 2 square minus 12 into 2 plus 20, and that is your answer, right? That is your answer. I believe the idea is very, very clear. Okay, Monisha had solved it, but I believe every kid can solve it right now. Okay, no problem, right? So I believe everybody can solve it right now. Okay, so 8 is the correct answer. Okay, now look at the other part. It is the question based on the kinematic equation. So free fall and all will come into this category. So let's look at that. So there are 4 options. I have written it. So the question is the displacement and the increase in the velocity of a moving particle in the time interval t to t plus 1. From t to t plus 1, the distance travelled is 125. From t to t plus 1, just 1 second is there. The distance travelled is 125 and the velocity achieved is 50 meter per second. From t to t plus 1, when the particle travels, the distance travelled is 125 and the speed it acquires is 50 meter per second respectively. The distance travelled by the particle in t plus 2th second is, the distance travelled by the particle in t plus 2th second is, understand the question first. This is, let's say, the journey between t second and t plus 1 second, right? It has travelled certain displacement. What is that? 125 meter. And the velocity the particle it has acquired right now is 50 meter per second, right? Particle might have some initial velocity, but at the end of the journey, it has acquired the velocity 50 meter per second. Now, another second, after another second, okay, you wait for another second. So you see that t plus 1 to t plus 2, right? In t plus 2th second, in that second, it had travelled certain displacement. You have to answer that, right? How much distance the particle has travelled in the next second, right? This is something you have to answer, right? So try to answer that in the chat section, okay? See, Shriyanshi is answering, right? Very nice. So the questions are very nice, as you can see, right? I have not picked very easy questions, right? Directly from the NEET exam and solve it, because PYQs we are going to solve later on anyway, right? When the exams will be nearing, we'll be solving PYQs. So right now it is our responsibility to solve slightly difficult question, right? So if you can solve these questions and understand these questions, solving PYQs will be a piece of cake for you, right? Okay, very nice. So let's look at that. Okay, let's look at that. Okay, how to solve it. So you see, right, if you start with the basic equation of v is equals to u plus at, right? So the journey is saying between t to t plus 1, the particle had traveled a certain distance of 125 meter and acquired a velocity of 50 meter per second. If I assume t is equals to 0, right? So final end of the journey time is 1 second, right? Yes or no? So initial velocity of the particle, if it is u, final velocity is u plus 50, right? It had acquired a velocity of 50. So final velocity is u plus 50. Okay. So for this journey, v is equals to u plus 80. If we apply, v is final velocity is u plus 50. Initial velocity is u. Time is equals to 1 second. At the end of it, time is 1 second, right? So a into 1. So from here, acceleration came out in this part of the journey is 50 meter per second square, right? And in the next part of the journey, from t plus 1 to t plus 2, again you have another second to move, right? So clearly, you have, in the same part you have applied, because the particle is traveling 125 meters. So s is ut plus half at square, you can apply, right? And once you do that, s is equals to ut plus half at square. From here, initial velocity is also figured out. 100 meter per second, that was the initial velocity. It had acquired a velocity 50. So 50 is the increment in the velocity. It started with 100, now it is 150, right? What will be the displacement in the next t plus 2th second? So displacement in nth second is u plus a upon 2, 2n minus 1. Instead of n, you can put 2, n equals to 2, right? So u is 100, a upon 2, acceleration is 50, 50 upon 2, and 2n minus 1. So 2 into 2 minus 1, that is there. So it is 100 plus 50 upon 2 is 25, and 2 into 2 minus 1 is 3, it is 75. So 175 is the answer which is written over here, right? So I believe the idea is very, very clear. Okay, I believe the idea is very, very clear, and if there is any question, you can definitely ask me. Yes, so let's move on and talk about the next one. So here is a vertical motion under gravity, right? So let's look at that and try to solve it. Basic formulas I have also written. You can download the notes and you can revise your basic formulas as well, right? Okay, focus, right? Look at this question. A body is falling under gravity. It covers 2 points. It is a very good question. Okay. Generally, the question from motion under gravity were very, very simple, my dear kids. But for this class, I had to work really hard to find question of this difficulty, which is matching up to the NEET level. But still, it is going to teach you 2 or 3 concepts, right? So if you just focus on this numerical, it will tell you something. Okay? 10th के लिए tips. अभी बेटा बहुत time है आपके लिए NEET के लिए. So just focus on it. So just focus over here. A body is falling under gravity. It covers point A and B separated by 80 meters. A body is falling under gravity, so acceleration can be considered constant. It is falling with acceleration g. Okay. It covers 2 points A and B which are separated by 80 meters. So understand that it is not saying it is falling by 80 meters. It is saying that it is covering 2 points which are separated by 80 meters. So you see that a body is falling like this, right? It might be starting from here and it falls till here, right? So at 2 points in the journey, let's say these are the 2 points. It has started here. Right now it is here at A. After some point it is at B, and then it is to the ground. Okay. So in the downward journey, there were 2 random points, right? And these 2 random points were 80 meters apart. Got it? Right. So look at that. A body is falling under gravity. It covers 2 points A and B separated by 80 meters in 2 seconds. So these 2 random points which are 80 meter apart are covered in 2 seconds, right? The distance of upper point from the starting point is from A to this point. This is the distance you have to find out, right? The distance of upper point A from the starting point. This is what you have to find out, right? So you can say that I'm giving you a hint. Try to solve it. Very good question. Let's say that from the starting point till this point, the time taken is t1. From the starting point to the other point, the time taken is t2, right? I'm telling you this basic part, right? And now you can try to solve it, okay? Because if you take the motion from the starting point, it is free fall, okay? From till A, the body will acquire certain velocity, yes or no? Body is dropped, it will regain some velocity, and at A, it will have some velocity, yes or no? Okay. So body is acquiring some velocity at A, and it is increasing, and it is acquiring some other velocity at B, okay? But if you consider this motion and this motion, let us say O is the starting point. If you consider OA and OB, they are the free fall, right? Think about that. If you consider OB minus OA, that is 80 meters. Try to solve it. That was the hint I gave you. And now you can solve it, okay? And you can take 50 seconds to solve. You can start it, okay? You can start solving this kind of question, okay? Now, we can easily look at these kind of questions and have a very clear understanding about it. So free fall is happening, clear, right? So you can say that S is equals to U plus V is U plus GT, and all those things are clearly applicable. This acceleration is G, right? But here they are talking about 2 points during the fall which are separated by 80 meters. So they are not saying from the starting point it is falling for 80 meters, right? So if you apply the concepts very clearly, right, you will get the answers without any problem. Shreyanshi is saying A. Very nice. Sorry, Surya is saying A. Asmita is saying A. Monisha is saying A. Let's say that. Let's see who is actually correct in this one. Right? Okay. Very good question. These kind of questions are very hard to find because they tell us, they help us to understand the gaps in our learning. Right? If I tell you simple basic formula, this question was asked in 2024, NEET 2024. That I will do later on. But the idea of this session is not to solve some PYQs randomly, because that is something you can do. The idea of this session is to teach you that there are some good questions and we can learn from those questions, right? There are some concepts we can get from those questions, right? So let's understand that. Okay. Right. Very nice, very nice. So I guess your time is over, and let's see that if anyone has answered it correctly, right? So yeah, so let's say who has the correct. Oh, Divya has given the correct answer. Shreyanshi has given the correct answer. Surya has given the correct answer. Ashmita and Monisha, all of them have given the correct answer, by the way. Nice. So clearly, I believe the kids are very smart. They can solve it. Okay. So right now you see that from the starting point till a point A, right, you can easily solve it. Let's say the time taken was T1, right? From the starting point, this was the starting point. This is the point A, this is the point B, and this is the ground, okay? So from here to here, it is S equals to, half GT square. U will become 0 for the initial point, right? S is half GT square. Let us say the time taken is T1, right? Between these two, the time taken is 2 seconds. So from here to here, it will be T1 plus 2 seconds, right? Because between these two, it was 2 seconds, right? So you see that this part, O to A, it is how much? Half GT1 square. The total will be half GT1 plus 2 whole square. Subtract them. This minus this is only this much, which is 80 meters. SB minus SA is 80 meters. Just put the values, and upon solving it, you will get the value of T1, right? Okay. And once you know the value of T1, you can calculate how far the particle will fall. Once you know the T1, you can easily calculate. S is ut plus half GT square. You can easily calculate the distance, half GT square. You put the value T1 is equals to something, 12 seconds or 3 seconds, and you can calculate it, right? So the idea is very, very clear. You have the 45 meters is the correct answer, right? Okay. Now look at the next one. Velocity in 2 dimensions. So basically we are talking about the projectile motion, right? So there are some basic formulas of projectile motion about the distance and all, right? So it is written at the topmost point in the NEET papers. They are very concerned about the velocity and the kinetic energy at the topmost points, right? So let's look at that. Here the questions, all questions were very, very easy. They were based on the simple formulas, right? So you can download the notes and get the formulas by default. Look at the question and try to solve it. It is from the NEET previous year itself, because all the questions from the NEET in this particular topic were really, really easy. So I gave you some easy questions from the projectile motion. Look at that. A ball is projected from the point A with a velocity 20 meter per second at an angle 60 degree to the horizontal direction. At the highest point B, the velocity of the ball will be? The ball is going like this. So at the highest point, what will be the velocity? That is, these are your options: 20, 0, 10 root 3 and 10. A, B, C and D. These are your options, right? Try to solve it, and here is your time, right? So 45 seconds will be enough. Even 30 seconds will be enough to solve this one, right? And your time starts now. Okay, right? A ball is projected from point A, right? So clearly you can understand and solve it. And I believe these kind of questions need not a very tough explanation. Very simple. Very nice. Ananya, Noun, Surya, Srinadha, Zoro, everybody is answering this one. Very nice. So let's see that who is giving the correct answer, right? So time is up now, right? And let's see that who is giving the correct answer, right? Okay. Okay. All right. So in the leaderboards, I can see Surya has given the fastest answer. Then you have Srinadha, then you have Monisha, and then Shreyansh. Very nice. So the formula is very, very simple, because at the topmost point, there is no vertical component of the velocity. There is only horizontal component of the velocity, which is v cos theta. So v cos theta is 20 cos 60. 20 cos 60 is 20 into 1 upon 2, which is 10. Answer number D is correct. So you don't need to solve it. You can solve it very quickly. Look at this question. A bullet is fired from the gun at the speed of 280 meter per second in the direction 30 degree above the horizontal. A bullet is fired like this. Okay. So you have to answer the maximum height attained by the bullet is. Again, a very simple question. It was also asked in previous year NEET 2023, not very old question. So you see that in NEET exam, the questions from this topic are very, very formula based, right? So the pattern, you understand that for the projectile motion, I don't need to solve very deep questions for the NEET exam, right? Okay. They ask you a very simple formula based question, and now you can answer it in the comment section. So I'm going to start the poll, and now you can answer it. So 30 seconds will be enough for this one, and try to answer it in the poll of this question. All right. So you see that simply you have to find the formula, apply the formula for maximum height of the projectile, and you can get it. Very nice. Yeah, just height you have to find, Srinadha. Very nice. Try to find it, and your time is up. So let's see that. So yeah, everybody has given the correct answer, and the fastest one was given by Srinadha, right? Nice. So let's see that. You know that when a projectile is thrown at an angle theta at a velocity u, the maximum height attained by the projectile in that particular case will be u square sine square theta upon 2g. U square sine square theta upon 2g, and just put the value. You are throwing it at a value of speed of 280 meter per second at an angle 30 degree. You just divide it, and you will have the final answer of 1000 meters, right? So I believe the idea is very, very clear. Look at this question. Again, a simple question from the projectile motion, and it was asked in the year 2022, right? Very simple question again. Look at that. A ball is projected with a velocity of 10 meter per second at an angle of 60 degree with the vertical direction. Now look at that. It is given 60 degree with the vertical direction, right? Read this part very clearly. Its speed at the highest point of the trajectory will be, its speed at the highest point, and the angle is given this particular part, right? Options are visible: 0, 5 root 3, 5 and 10, right? Try to answer it, right? You have 30 seconds to answer, right? You have 30 seconds to answer. Okay. Yeah, Monisha, I have seen it. So now you can answer it. All right. So I hope the idea is very, very clear. Okay. So here we have to answer. But just one thing was there in this question. The angle was given from the vertical direction, right? So if you are throwing a projectile and they are not giving you the angle from the horizontal, they are giving the angle from the vertical. But you know that in all the formulas, this angle is taken from the horizontal. They are giving you this angle is 60 degree. So just know that in the formulas, you have to put theta as 30, from the horizontal angle will be 30. Everything else is simple, right? Its speed at the highest point is going to be v cos 30, right? If u is the velocity, then u cos 30, right? And you know that 10 cos 30, cos 30 is root 3 by 2. So yeah, you know, root 3 by 2. So clearly 10 into root 3 by 2, 10 into root 3 by 2 is 5 root 3. So option B is correct. And yeah, 50% kids have given the correct answer. Monisha was correct in this one, right? Nice. Okay, let's look at the next one. Now the next questions are coming from laws of motion. Again, in the NEET exam, very simple questions are asked from this chapter as well, laws of motion. You can get some concepts from this one as well. So try and understand it, what kind of questions you can expect. And there will be some learning in these questions as well. So I have few questions from this chapter of laws of motion. Let us very quickly revise it, right? So again, I have placed certain concepts to revise, right? So you can just go through it and you can revise the concepts, and now you can solve this particular question. This is the question and these are the options, right? So let's read the question first. There are 3 blocks. They are connected with strings. These strings can't be extended, okay? Now, the tension T1 and T2 are in the strings are T1 and T2 we have to find out. And you know that how to find out these kind of solutions of these kind of problems, right? You see, when the systems are moved by a common force, right, and the rope connecting link between them is not extensible, right, you cannot extend it, then they all share a common acceleration. This is the hint I gave you, right? The rope between them can't be extended. You have to find the tensions T1 and T2. So I will tell you that in such situations, all the particles will share the common acceleration. You see that if I apply a force, all 3 particles will move ahead by the same amount, and acceleration will be common for all of them. Acceleration is common for all of them. Okay. So just look at that acceleration, get the value of acceleration first, look at the FBD then, and think about what will be the values, right? So 30 seconds will be enough for this kind of question, and I will put the options here, right? So just options are very clear, I believe, right? Okay, so try to solve it and let us see how many kids are giving the correct answer and who is giving the answers first. Okay, let us see. Very nice. Shriyanshi, Zoro, nice. All right. Yeah, time is up. All right. So let's see. Okay. Who has given the correct answer? Zoro has given the correct answer, and Shriyanshi has also given the correct answer. Very nice, right? So the idea is very, very clear. The common acceleration will be that force, pulling force upon total mass, right? So pulling force is 80, total mass is 5 plus 3 plus 2, it is 10 kilograms. So acceleration will be 80 by 10, which is 8 meter per second square of this entire system of masses, right? Once you know the acceleration is there, right? Now you look at the FBD of any of these blocks. So this block is under the action force of T1 and the net is M into A, right? So just T1 is equals to M into A1, 5 into 10. So from there you can calculate the value of T1, right? Okay. So over here you have it, right? You see that 5 is experiencing a force of T1, right? Just separate it, right? Separate it. So 5 is experiencing a force T1, right? Like this. So you see that the mass into acceleration is T1, so which is 5 into it is 40, right? Similarly, the second block is experiencing T1 here and T2 here. So you see that T1 and T2 are there. The second block is of mass 3 kilogram and it is moving ahead with a common acceleration A of 8 meter per second square. So clearly T2 minus T1 is equals to mass into acceleration 3 into A, 8, right? So from here T2 can be calculated. So no problem with this kind of problems as well. So look at another kind of problem, right? Now in this one, many kids do a simple mistake, but they don't take the value of theta very correctly. So you know that in this kind of situation, if this angle is theta and a block is placed, the weight mg is hanging off the block like this, right? If this angle is theta, this angle will also be theta, right? Okay. So the plane makes an angle theta from the horizontal. Normal to the plane also make the same angle from the vertical, right? Okay, so knowing that, you can solve similar questions like this. And it's a simple pulley based question. Again, net pulling force upon total mass. This is the concept I have told you in the one shot videos as well, right? Yes, Ayush. So let's have a look at that. So here you can look at this particular question and try to solve it as well. So here we have a light string passing over a smooth pulley. It has a mass m1 and m2, right? Two blocks m1 and m2, the acceleration of the system is g by 8. Then the ratio of masses will be, what will be the ratio of masses m1 and m2? This is something you have to answer, right? So you can answer it. Okay. Okay, try to answer it. It's a single choice question. So yeah, you can answer it. Okay. All right. So try to answer it. How many lessons today? So we'll be doing the entire physics, right? So everything that seems to be important from the NEET perspective, all the patterns I've picked, and those patterns will be completed today itself, right? All right. So try to solve it. Okay. Nice, very nice. Shreyanshi, Monisha, Divya, they are giving the answers. And let's see that what kind of answer are we getting? Are we getting the correct answer or not? Right. So yeah, we got the correct answer. And who gave the correct answer? Shreyanshi has given the correct answer. Surya, Kanva, Zoro, they all give the correct answer. And let's see that, right? You see that the acceleration of the system will be net pulling force upon total mass. So you see, net pulling force will be m2g minus m1g, or m1 minus m2 into g, you can say that, upon total mass is m1 plus m2. So you see, subtract it, it will be simply g by 8, right? And now if you just solve it, the net acceleration was g by 8, it is given in the question. And if you just solve this equation, g and g cancels out. So 8 m2 minus 8 m1 minus 8 m2 is m1 plus m2, and you can solve and get the ratio m1 upon m2, 9 by 7, which is the option B, right? Move on and talk about this particular question, right? Again, I have to give you a hint of this question as well, right? If the surfaces shown in the figure are frictionless, and the pulleys and the string are light, the acceleration of the block of mass 2 kg is, the acceleration of this block we have to find out, right? Clearly, this rope is going to feel some tension. And what will be the tension in this rope? How can we get that particular value? Think about it. If this is experiencing a tension force like this, right? You see that the tension force in the entire string will be same. Let us call that tension as T, right? So it is being balanced by a downward force, right? So the tension in the downward string will be double of that, right? So think about it and try to solve it. And what will be the relation between the acceleration? Think about it. This block can move by 1 meter. So to do that, this side has to move 1 meter, and this side also has to move 1 meter, right? So clearly, when this block moves by 1 meter, it takes the upper rope by 2 meters, right? 1 meter on each side. So this one has to move double of that. So if this has acceleration A, the other block will have acceleration 2A, right? This is something we can get from the common sense, right? So relation between acceleration I have told you, right? And now you have to tell the acceleration of mass 2 kg in this situation, right? Now you have to tell the acceleration between the mass 2 kg in this situation. So again the pole is there, right? Again the pole is there. Okay, try to solve it. You have the acceleration of the block of mass 2 kg. It is g by 2, g by 4, g or g by 3. Try to solve it. All right. Shreyansh is giving the answer. Nice. Shubham is giving the answer. All right. All right. So let's see who is giving the correct answer in this particular situation. So let's say the time is up or not. So time is up. And let's see that who is giving the correct answer. right? So here the option D is correct. So yeah, we got the correct answer from Shubhanshi, Monisha, and Shreyanshi. All three of them gave the correct answer. So let's see that if how to solve this one. So clearly the relations are very clear, right? And you can draw the FBD very easily. This one will have acceleration a downward, and this one will have acceleration 2a in this direction. And once we know the direction of acceleration and the relation is a and 2a, you can easily make the FBD of these two, right? You can easily make the FBD of any of these two masses, right? So this is the simple formula, simple FBD, right? And now look at that. 40 minus 2t. So 40 is the weight of this thing, right? Look at the FBD of this block. 40 is the weight, m into g acting this way. 2t is the tension acting upward. So 40 minus 2t is equals to mass into acceleration, 4 into a. This is for the this block, right? And now look at this other equation. It is tension in the rope is pulling it upwards, T, right? Tension in the rope is pulling it upward, and the downward force is the weight is acting downward, which is 2 into g, 20 Newton, right? And in this way, it is going to be 20 cos theta, 20 cos 30, and in this way it will be 20 sin 30, right? So sin 30 is 1 upon 2, 20 into 1 upon 2 is 10, okay? So you see that T minus 10 is equals to mass into acceleration, 2 into 2a, which is 4a. T minus 10 is 4a. This is for the second block, right? And now once you know the values, you can easily solve it to get the value of acceleration of a, which is g by 2a is equals to g by 3. Acceleration of this block you have to find out. Know that upon solving you get the value of a only. A tells you the acceleration of 4 kilogram block. You have to tell the acceleration of 2 kilogram block, which is 2a, right? So it is going to be g by 3. All right. So I believe the idea is very, very clear. Right. Now you look at another question and try to solve it. Here you have a wedge and two bodies are there. Capital M and small m are there. Right. This angle is 53. This angle is 37. This block wants to move downwards. Clearly the other block will move upward. Right. Question on constraint motion. Right. This block will move downward. The other block will move upward. You have to find the coefficient of friction between the surface is given 0.25. The coefficient of friction is given 0.25. So this block is moving downward. Friction on this one is acting backward, right? This is how the friction is acting. This one is moving upward, right? The friction on this one is acting backwards like this, right? Okay. And what will be the value of friction? Mu into n. You know that, right? Now, what will the value of friction? Mu into n. Okay. So upon knowing that, you can solve it. And tell that in the given arrangement of doubly inclined plane, two blocks of masses m and small m are placed. The blocks are connected by a light string passing over an ideal pulley as shown in the figure. The coefficient of friction between the surface and the figure is block is 0.25. The value of m, the value of small m, for which capital M is 10 kilogram. Capital M is 10 kilogram. It will move down with an acceleration of 2 meter per second square. Okay. So the capital M, this one 10 kilogram should move 2 meter per second square. What should be the value of small m for that? Right. So you have to answer that. Again, you have to look for the FBD of this one and this one. You will get two equations, and upon solving those two equations, you will get the small m. Right. So these are all the hints you have. FBDs and all I gave you. And now you look at yourself and try to solve it. Again, you have your time, 45 seconds, let's say, and start solving it. Okay. Try to solve it. So you have 4.5 kg, 6.5 kg, 9 kg, and 2.25 kg, right? Look at that and try to solve it. Not Sudhanshi, I'm Sania. Okay, Sania. All right. So questions are good, right? And kids who are preparing well should be able to solve it. But kids who are only solving simple questions might expect a shock from the NEET exam, right? There are certain chapters that may ask you slightly difficult questions. So I want you to be prepared for those ones, right? And questions that are always easy, there is nothing to worry about, right? Okay, so I believe the time is up. And let's say that how many kids are giving the correct answer, right? Let's say how many kids are giving the correct answer for this particular question. Okay. All right. Just a second. All right. So let's see. Oh, Alright, so these 7 kids gave the correct answer. Shubhanshi, Triya, Shreyanshi, Kanva, Ashmita, Monisha, and Divya. They all gave the correct answer. That tells a lot about your preparation, right? That you guys are preparing so well that even in this kind of serious session as well, you can solve it, right? So yeah, so you have, once you look at the video of each of these diagrams, just look at the direction of friction, right? So you see that this one will have weight acting downward, mg. So the component of this acting in this side is going to be, you know, mg cos theta or mg sin theta. You see that mg cos theta acting downward and mg sin theta is acting this way, right? So you just solve it, and m into a, this minus this is equals to m into a, right? And tension force are acting in this way as well. So just try to solve it and you will get your answer, right? So here you have it. Here you have mg sin theta acting downward, tension forces are acting upward, and this block is moving down. So friction on this block is acting up, right? So mg sin 53 minus T and F, that is representing m into a, right? Net force is equals to mass into acceleration. Net force is equals to mass into acceleration. So what is the net force of this block? Mg sin 53, right? This is downward, and upward forces are T and F. Minus T minus F, that is equals to mass into acceleration, which is 2, right? And mass is how much? 10 kilogram, right? So solve it. You get an equation of T and F in this situation. What will be the value of friction force? Mu into normal reaction, right? What will be the normal reaction? Normal reaction will be equals to this particular component, right? Which is mg cos theta, mg cos 53. So just put it and you will have the value, right? 10g, it is mg cos 53. This is the normal reaction, and multiply that by mu. This is the friction force, right? This is the friction force we are talking about. Mg mu into mg cos 53, right? So you see that everything is written over here. 10 into g sin 53 minus friction force is mu mg cos 53 minus tension force is equals to mass into acceleration. Upon solving, tension force came out to be 45. This is the FBD of first block. Similarly, you look at the FBD of a smaller block and you can solve it similarly for the other one, and a small m can be figured out, right? So I believe these kind of questions are easier. One kid is saying something, so just a second. Saying, sir, Sania, please call me Sania. Acha. Okay, all right, I'll call you Sania, whatever. So look at this question. A block of mass 5 kg is placed on a rough inclined surface as shown in the figure. Okay, this one. If F1 is the force required, a very good question. Very, very good question. All right. The questions are, mostly the questions are very nice, right? So all the questions are going to tell you something. This question is about friction, and this question is again going to tell you something, right? Very good question. Look at that. A block of mass 5 kg is placed on a rough inclined surface. A block of mass 5 kg is placed on a rough inclined surface like this, okay? If F1 is a force required to just move the block up the inclined plane, if F1 is the force required to just move the block up the inclined plane, all right, F1 is the force required to just move the block up, right? So if you apply force higher than F1, the block will start moving in the upward direction, okay? If you apply the force higher than F1, it will start moving in that upward direction, right? So F1, force higher than F1 will move the block upwards, all right? So think about it. When you are applying F1, the tendency in the block is to move upwards. So where will the friction act in this case? The friction wants to act downward, clear? And the limiting friction will be acting in this situation. Why? Because the block just wants to move in the upward direction. Look into the second half of the question. It is saying F2 is the force required to just prevent the block from sliding down. Think about it. F2 is acting to prevent the block from sliding down, right? So in absence of F2, the block wants to move downwards. Clear enough, right? So think about it. In absence of F2, or you say that when F2 is acting, in which direction the block should act, right? F2 is the force required to just prevent the block from sliding down, right? Look at that. So in which case, in which direction F2 is the force required to prevent the block from sliding down, right? So in which direction the friction force will be acting in this situation, right? F1 is the force that you need to is that at which the block just starts moving up. F2 is the force at which the block is prevented from sliding down, right? The direction of limiting friction will be different in both cases, right? And this is why I have chosen this question, right? Understand that the concept is very simple. Concept is how to take the direction of limiting friction. You know that when a body is just about to move, the value of static friction between the surface will be maximum. We will call it limiting friction. And the direction of limiting friction is opposite to the tendency of motion. Tendency of motion, right? So you have to tell me where will be the tendency of motion in both cases. And once you figure out that part, this question is easy. There is nothing in this question after that, right? And you can answer it any of these things, right? So just take your time and try to answer it, okay? So take a 30 seconds and answer it, okay? Yeah. So try to answer it. Yes, Sanya. Sanya is saying A. Okay. Triya is saying A. Okay. All right. Very nice. Crazy. Let's see. Poll has stopped. And let's see that who has given the correct answer. If anyone has given the correct answer or not. Yeah. Oh, this is Sanya. Sanya has given the correct answer. Divya has given the correct answer. Shreyanshi has given the correct answer. Monisha and Kanva. Everybody has given the correct answer, yeah. Nice. Right? That means these kids are doing some serious preparation. Very nice. All right. So I believe the idea is very, very clear. Right? We just have to think about the tendency of motion in this situation. We just have to think about the tendency of motion. What is F1? F1 is the force. F1 is the force required to just move the block up in the inclined plane. So when the F1 is acting, the tendency of the block is to move upwards, and in that case, because the tendency is to move upwards, the limiting friction will act downwards, right? Tendency of this force is to move upward, the limiting friction mu mg cos theta, right? This will act downward, and everything else is easier, right? After that, mg sin theta is anyway going to act down the plane. Mg sin theta is always going to act down the plane. No worries about that. Now, F2 is the force, this is F2, right? F2 is the force that prevents it from sliding down. So, in case of F2, the body wants to slide down, right? And because the body wants to slide down, the friction force will be opposing that. It will act upwards. So, mu times mg cos theta, mu into n. N is mg cos theta, right? It is going to act upwards, right? So, this is the case, right? And you just, you say that this is the limiting friction, Fl. Right, it is this mu mg cos theta, and the direction will be opposite in both the cases. Once you know that friction force in the first case, the situation is very simple. Net force is equals to mass into acceleration in the first case. So F1 is equals to mg sin theta plus Fk. F1 does that. F1 is balancing that because we are in the limiting situation, right? When you have this force, body is just about to move. So F1 is balancing these two, and F2 is balancing these two. Clear? Once you do that, you have these two equations, and from that F1 minus F2 can be figured out. 5 root 3. No problem with that, right? Now look at the other question, right? Centripetal force mv square by r is m omega square r. That means we are into the circular motion now. Look at this question, try to solve it. From the circular motion, the questions were mostly very, very easy, right? You just have to apply the basic formula and you will get the answer, right? Already answered before the poll, sir. Very nice, Surya. No problem, right? So let me just ask you this thing, right? And I'll give you the poll before I start my explanation, because some kids answer before I start the poll, and that is why their options are not included in the poll, right? So try to answer it, and now you can look at the question as well. Right, you can read the question as well. So I can read it for you as well. A ball of mass 0.5 kg is attached to a string of length 50 centimeter. The ball is rotated on a horizontal circular path about the vertical axis. The maximum tension that a string can bear is 400 Newton. The maximum possible value of angular velocity omega in radian per second will be. Of course, when you rotate it in the circular path, what happens? a force is trying to break that particular string, right? A force is acting outwards on your, that you can feel it on your finger. You're rotating it. A force is trying to pull it away, right? What is that? Mr omega square, right? And maximum value that you can have over here, right? You have to answer that. Okay. Very nice. Very nice. All right. So let's see who is giving the correct answer. Oh, so everybody has given the correct answer. Nice. So Shreyanshi, Shriya, Sanya, and Kanva, everybody has given the correct answer. Let's look at that. 40 is the correct answer. And it's just a formula based question, right? So Fc is mr omega square. So this is the maximum possible situation, right? So mass of the ball is 0.5, radius is given, omega is something we have to calculate. You know that when you have the maximum possible value, so under the situation, the rope will break if the centripetal force is higher than the tension the rope can bear. So the maximum possible value is this 400. It cannot take beyond that, and it is mr omega square. So omega will be simply 40 radian per second. Just solve it and you'll have it. Okay, so let's move on and talk about the next question. If the radius of curvature of the path of two particles of same mass are in the ratio 3:4, radius of curvature of path of two particles of same mass in the ratio 3:4, then in order to have constant centripetal force, their velocities will be in ratio of which of these two things? Right, the radius of curvature of the radius of curvature of the path of two particles of same masses is 3:4. Then in order to have the constant centripetal force, this kind of question is repeated, right? It's a repeated pattern, right? So they ask you about the ratios, right? Try to answer it. Let me give you a poll, right? Now if you have answered it already, you can answer it again so that your poll can be recorded, right? Okay, so try to answer it. Okay, what do we want? We want they should have constant centripetal force. So mv square by r for the first one is same as the mv2 square by r2 for the second one. From here, r1 upon r2 is given. So v1 upon v2 can be figured out. Very easy. All right. So let's see that who has given the correct option. Okay, so the time is up. And let's see who has given the correct option. Just a second. Okay. So yeah, I can see that 100% gets given the correct answer. So Shreyanshi, Subodh, Priya, Sanya, and Surya, all of them have given the correct answer. Kanva has given the correct answer, and Ananya also has given the correct answer. Nice. Right. So the option was root 3:2. So clearly, what do we want? We need to have constant centripetal force. So both the particles should have the constant centripetal force. That is, centripetal force for any particle is mv square by r, and we want that to be constant. So mv square by r for this one and mv square by r for the second one should be same. So we did that. m1 v1 square upon r1, m2 v2 square upon r2, that should be same. Masses are already same. So clearly we can say v1 upon v2 is root r1 upon r2. Ratio of radii of curvature is given 3:2. Just put the value 3:4. So 3 upon 4, right? Under root 3 upon 4 is root 3 by 2. Okay. All right. Let's look at the next question, right? This is the requirement. If I want a particle to stay on a circular path, right? These are the equations, banking of the roads, right? And if I want to bank the road, right? I don't want a particle to skid away from the circular trajectory. I have told all that in the chapter of circular motion, and I've also given you the one shot of the same chapter itself, and all the concepts are basically from the same one shot video, right? So look at this question and try to solve it. A car is moving with a constant speed of 20 in a circular horizontal track of radius 40. A bob is suspended from a roof of the car by a massless string. The angle made by the string with the vertical will be. The angle made by the string from the vertical will be. Right. Okay. So what will be the angle made by the vertical? So very simple question. Very simple question. Simple question. Okay. These kind of simple formula based questions you can expect from the NEET exam. So let me give you the poll. Right. Start. All right. So from the circular motion, mostly the questions are based on the formula itself. So if anyone has done the basic, formula revision very clearly, they can solve these kind of questions very easily. Okay. The angle made by the string with the vertical. So there is a car, and from the roof of the car a string is hanging. The vehicle is taking a turn. So of course this particular thing will take a angle, right? So what will be the angle from the vertical? So let's see that how many kids are giving the correct answer. Yeah. Shreyanshi, Surya, Sanya, Kanva, Ananya, Triya, Subodh and Divya. They all have given the correct answer. So let's see that, how to solve it. So again, very simple approach. Tan theta is equals to V square upon RG. We can simply apply that here. Right. So this is the roof of the car, and from that this bob is hanging. When it will take a turn, it will move away, right, because of the effects of centripetal forces, right? So once it happens, right, and we can apply the FBD of this bob, right? This bob is over here. You look at that. The weight is acting downward, right? The outward pseudo force is M into A. This is A is the centripetal force basically, and this one has tension force, right? So once you equate all of that, you simply have tan theta is equals to A upon G. A is nothing but this centripetal force, just centripetal acceleration. Put the values. You simply have tan theta is equals to V square upon RG. Tan theta is equals to V square upon RG. Okay. So just put the values and you have the answer 45 degrees. No problem about that, right? Now the next question is from the work energy power. Let us very quickly look at that as well. So these are the simple concepts from the chapter, right? Now this is the most important concepts, right? If you get questions from this particular chapter in the NEET exam, it is very highly likely the question will be from the work energy theorem, right? I have seen the previous year papers, right, and I found that NEET repeatedly asking the questions from work energy theorem. Here I have picked many questions of the same nature. Let's look at that and try to solve it. Okay. Here you have the question first. A body of mass 0.5 kg is traveling on a straight line path with velocity 3x square plus 4. The net workload by the force during its displacement is x equals to 0 to x equals to 2 is. What will be the force during this displacement? Very simple question, right? But all these questions you can find them as good, right? So try to solve it, and let me give you a poll. So most of you should be able to solve it at this moment. But if you are not able to solve it, don't worry about that. I will teach you, right, what concept is applied in this particular situation. Okay. Particle of 0.5 kg is moving with that velocity. What will be the work done between this displacement and that displacement? Think about it. At different values of x, velocities can be figured out. They are giving you velocities. They are talking about the work done. How is work done related to velocities? Okay, velocities can be linked with kinetic energy, and kinetic energy can be linked with work done. Yeah, by work energy theorem, right? So what is the work done? Change in the kinetic energy. At different values of x, I can get the values of velocity. I can get the values of kinetic energy, half mv2 square, half mv1 square. Difference of that kinetic energy will be the work done on the particle, right? So let's see who has given the correct option, right? Some kids have given the incorrect option as well, but most kids have given the correct option. And the fastest option was given by Surya, then Triya, then Kanva, then Ananya, then Shreyanshi, then Sanya, and Divya. All right, so very nice. All right, so have a look at that. So we know that velocity at x equals to 0, v is given as 3x square plus 4. At x equals to 0, velocity will be 0 plus 4. This is 4, right? So 4 meter per second. And at x equals to 2, put x equals to 2. So 2 square is 4. 4 3s are 12, and 12 and 4 16 meter per second, right? So over here you can get the kinetic energy. Over here you can get the kinetic energy. Difference of that will give you the net work done. Okay, because work done is equals to change of kinetic energy, right? Simply you can get that 60. So option C is correct. Look at this question. A particle of mass 500 gram is moving in a straight line with a velocity this. Velocity of the particle is again b into x to the power 5 by 2, right? These are the best questions I could find on this topic. However, the questions that were generally asked from the topic are much easier than this one, right? This is the velocity of the particle, b x to the power 5 by 2. The work done by the net force during the displacement from x equals to 0 to 4 is, again, very simple question. If you have understood the previous question, this question should be a piece of cake. Again, the time starts now. Right? Now you answer it. Now your answers will be recorded by the poll. Right? Very nice, Surya. Right. So every question is going to teach you something, and these are some good questions, you can say. We can have even better questions, but solving those questions at this point doesn't make sense because that they take up a lot of time, and we don't have that right now. Okay. So these are the good enough questions that will help us to learn one or two concepts. Every single question will teach us certain concepts, and those concepts are something that are repeated every time. Nobody can predict the questions, but patterns can be predicted, and that is what we are trying to do. Okay. So let us see how many kids are giving the correct answer in this one. So here it is. Oh, everybody has given the correct answer. So the fastest answer was given by Triya this time, and then Shreyanshi, then Surya, then Sanya, and then Kanva, right? And then Divya, and then Monisha. Let's see, right? So here you can clearly get that, right? Velocity at x equals to 0 you can get, velocity at x equals to 4 you can get, right? And once you know the V1 and V2, you can get K1 and K2 as well, kinetic energies. Difference of that kinetic energy will be the work done by work energy theorem, right? So look at that. Right, the work done is change in kinetic energy, half K2 square minus K1 square. Right, so just do that and get the value of kinetic energy. Now you have the power. Now, from the concept of power, what we have seen, right, as they are more interested to figure out what will be the value of work, and they'll give you velocities, right, and they want you to find work because work is related to velocity through kinetic energy, right? Interesting concepts are in this way. For the power as well, work done, power can also be related with velocity, right? And there are questions that are considered to be good questions from the concept of power. They are also linked with velocity. How? As you can see, power is work done per unit time. We know that, right? But work done is force into displacement, and you know time is also there. So ds by dt, rate of change of displacement, is velocity. So you see that instantaneous power is force into ds by dt, which is velocity. So force into velocity is instantaneous power. No worries about that. So if you know the velocity, you can calculate the instantaneous power of the something as well, right? And based on that concept, I could find some good questions. Let's solve it, right? Have a look at this question. A body of mass 2 kilograms moves under the action of time dependent force, this, right? The net power developed by the force at time t is given by. What will be the net power developed by the force? What will be the net power developed by the force? And again, you will have your poll, and you can answer it through the poll, right? And I'll see how many kids can easily solve it, and if you cannot solve it, I will tell you. All right. So you know the value of force this time, right? And the power developed by this thing. Think about it. Power, if you think just one formula is there for the power, power is work done per unit time. They're not talking about time in this way. They're not talking about work done in this situation. So what else can work in your favor? You know the force, you know the mass, right? By looking into the force, which is a function of time, if you divide the force by mass, you get the acceleration. And from acceleration, differentiating velocity gives you acceleration. So integrating acceleration will give you back the velocity, right? So by dividing it by mass, you can get acceleration, right? Force by mass is acceleration. And if you integrate acceleration, you can get back your velocity, right? Force and velocity can give you power. Force vector dot velocity vector is the power, right? Think about it. The approach should be very, very clear. Let's see how many kids are giving the correct option in this situation, first of all. So the option is here. Oh, some kids are trying and some kids are giving the correct answer. So let's see that. Triya has given the correct answer. Sanya has given the correct answer. Shreyanshi, Ananya, Veena, and Monisha. Okay, if you are not able to give the correct option, so no need to worry about that. The concept is very simple. So here, Generally, when we think about the power, we think about work done per unit time. We don't know the value of work done in this situation. Work done is force into displacement. Do we know the displacement? Can we calculate displacement? No. So we have to think about something else. Power is also force and velocity vector, product of these two, right? Can we get that? Force vector is given. Velocity vector, can we get velocity vector? Yes. From force vector, if I divide the force vector by mass, I will get the acceleration vector. Yes or no? Mass is given, right? So divide by 2 in it. So it is going to be 3t I cap and 3t square j cap. That will be acceleration. What is that? 3t I cap, divide the whole thing by mass, which is 2, 3t I cap plus 3t square j cap. Now you have the acceleration. If you integrate acceleration, you get velocity. Differentiating displacement gets velocity. Dx by dt is velocity. Differentiating velocity gives you acceleration. So if you go back, integrate acceleration gets velocity, integrate velocity get the displacement, right? So do that, integrate acceleration and you will get velocity. Once you have velocity, force into velocity is power, right? You have it, right? You have force given like this, acceleration divide force by mass, you get acceleration. Velocity is integration of that, right? Integration of that, just integrate it, right? And power is force into velocity vector. This vector into this vector, just multiply, because dot product we have to take. So the coefficient of I need to be multiplied and coefficient of j need to be multiplied and then added. Simply we can figure out, right? So now let's move on and talk about one more question on the similar concept, and this one is also a good question, right? These questions I have picked so that it can challenge your way of thinking, right? So it's not just to give you a feel good, right? By solving some simple previous year question. That is something I don't want to do, right? 150 previous year questions you can do at your home, right? Solutions are also given in the same previous year question book. Solve this, right? If the same maximum load carried by an elevator is 1400 kilograms, right? Maximum load carried by the elevator. So what load is carried by the elevator? The weight of the box of the elevator and the people inside it, right? So what is that? 600 kilogram for passenger and 800 kilogram of the box of the elevator, which is elevator can maximum load it can take is 600 plus 800, which is 1400 kilograms. So how much force it can carry? Maximum. So 1400 into g, m into g, that is the maximum force this elevator can carry, okay, which is moving up with a uniform speed of 3. So elevator, it can carry 1400 into g, m into g, upwards. This is the maximum load at 3 meter per second. We have to, frictional forces are 200 Newton, 2000 Newton. The maximum power used by the motor is, right? We have to talk about the maximum power used by the motor. Think about it, right? There is a motor. This is the rope of the elevator. The rope of the elevator is wounded on a motor. There is a motor over here. This motor is rotating and the whole thing is moving up, right? Simple structure is like that. This motor needs to have some power, some wattage, right? So the same elevator, if it is moving very quickly, the wattage of the motor will be very, very high. The motor is very powerful. If the motor is pulling them slowly, then motor is less powerful, right? Okay, so yeah, try to answer it in the poll, right? I forgot to give you the poll. So try to answer it in the poll. Oh, come on, stop poll. Right, let me first give you some numbers as well, so that you can answer it, right? Because this question is not giving you the options by default. So I'll give you some numbers, right? That will help you to give options. So let us say that option A is 60, option B is, option is something you have to give in kilowatts, right? So 60, 48, 50 and 100. Okay? So these are the options you have, right? Okay, try to answer it. Okay, and the option is in kilowatts, right? So these are the options you have. Now you can answer in the poll. All right, now you can answer in the poll. Good question. And after that, we will start another chapter, revising another chapter. Gradually, we will cover everything, right? So good one. Now, if previously you have given the answer, now that is not recorded by the poll. Now quickly just put the answer so that it can be recorded by the poll, right? Jaldi jaldi. It is now ending up. Quickly put the answer in the chat box. Those who put the answer after the poll is started, that is only picked up by that, right? So I believe the idea is very, very clear. Okay. Oh, everybody gave the correct answer. And the fastest answer was given by Mursaleen. Then you have Sania, then you have Kana, then you have Srinanda, and then you have Shreyanshi, Triya, Ananya. Okay, good. So let's see. Right, how to solve it? Again, the maximum value of force that can be pulled, F is 1400 into G, right? The maximum velocity that it can move with 3 meter per second, right? So simply, and there is a friction force also. So what is the maximum force it is dealing with? Mg plus that frictional force, right? So mg plus that frictional force. Total weight is m into g, right? 1400 into 10, 14,000 Newton. But there is also frictional forces. So what is the maximum tension force in the rope? What is the maximum tension force in that rope, right? It is the weight, which is 14,000 kg, 14,000 Newton, sorry. And there is a friction force acting opposite to the movement. This thing is moving upwards. Friction force is acting 2000 Newton in the opposite direction of motion. So the tension force in this thing is 2000 plus 14,000, so which is 16,000, right? This is how much force it is dealing with, right? And still it is moving with 3 meter per second. So power is force into velocity. 16,000 into 3, it is 48,000 watts in kilowatts, divide by 1000, it is 48 kilowatts. That's it. Now you can move on, talk about the concepts of rotational motion. Now rotational motion seems to be a big topic, but you concern from the NEET exam. They generally ask questions around moment of inertia, right? And they are concerned more about individual particles, right? So I analyze those patterns, right? And instead of looking at every part of the chapter, I said, let's pick the questions from those topics, right? So from the rotational motion, these kind of questions were asked many times. So you see that there are multiple particles about a certain point. How will you figure out the center of mass of a certain system of particles? This is something it is very important. And now similar kind of concepts, a moment of inertia, how can you figure out for the system of particles? Look at the question, try to solve it. The identical is sphere, each of mass 2m. They are placed at the corners of a right angled triangle. They are placed at the corners of a right angled triangle. Okay. With mutually perpendicular side equals to 4 meter each. This is 4 meter and this is 4 meter. At the point of intersection of two sides is origin. Take this as origin. Okay. The magnitude of position vector of the center of mass of the system is 4 root 2 by x. What is the value of x? I will give you the option. Right. Try to solve it. Right. Right. I'll give you the option. Try to solve it. What will be the value of x? Right. So the options are 6, 5, 12, 3. Right. This is something you have to answer, and this is something that is going to take some time. So let's take 1 minute and try to solve it. Okay. Right. Take 1 minute and these are your options. Try to solve it. Okay. So what is happening? There are 4 particles and you have to talk about, there are 3 particles and you have to talk about location of center of mass. So location of center of mass m1 x1 plus m2 x2 plus m3 x3 upon m1 plus m2 plus m3, right? Yes or no? And similarly, position vector for this particular thing is this 4 root 2 by x. So how to find it? Clearly you know that, right? If x coordinate of center of mass is this, y coordinate of center of mass you have figured out, m1 y1 plus m2 y2 plus m3 y3 upon m1 plus m2 plus m3. X and y coordinate of center of mass you have figured out. The position vector of center of mass will be x coordinate I cap and y coordinate j cap. The magnitude of position vector of center of mass will be under root x square and y square, right? This is something which is given, 4 root 2 by x, right? So just apply the formula, get the value of x position of center of mass, y position of center of mass, and from that you can get the value of r and you can further solve it. Very nice. Okay, the poll is stopped. Let's see how many kids were able to solve it. If you were not able to solve it, no worries, I will tell you how to solve it, right? Let's see. Oh, all right. Kids are solving things. Nice. So Triya has solved it. Shreyanshi has solved it. Kanva has solved it. Sanya has solved it, and Ananya and Murshleen has solved it as well. Nice. So the idea is very, very simple. The concept I have already told you, right? So X position of center of mass and Y position of center of mass can be found out very, very simply, right? The setup is very, very simple again. So here you have this kind of setup. One particle is here, another particle is here, another particle is here, right? So this one is 0, 0, this one is 0, 4, and this one is 4, 0, right? So these are the setups, right? And once you do that, X and Y position of center of mass are this, right? M1, X1, M2, X2, and M3, X3 upon M1, M2, X3, and similarly like that, right? And position vector will be, right, under root this square plus this square. So this is how you figure out the magnitude of position vector. Instead of X, you have 4 root 2 upon X. Instead of X, you have 3, right? They are giving you the position vector of X, center of mass is 4 root 2 by X. Here you have 4 root 2 by 3. Instead of X, you have 3 only, right? Very simple numerical, right? Now, you have value of moment of inertia. Now, from the previous year NEET examinations, I found out the questions from the moment of inertia were fairly simple, right? The best questions from the concept of moment of inertia were from two parts, right? They were either from this portion, like there is a body and something is removed and all, right? Or there is a system of particle, this particle is there and this particle is there. Calculate the system moment of inertia about this point for this entire thing, right? We can calculate for that, right? And there were questions like this. There is this particle, calculate the moment of inertia about this axis, right? So questions on the concept of parallel axis theorem and perpendicular axis theorem were asked repeatedly from the moment of inertia. Especially the concept of parallel axis theorem was asked multiple times, right? So I have picked the question from that part itself, and here in this list I gave you multiple geometries and their moment of inertia. So this is for you. You can take the notes and you can revise it, right? So center of mass and moment of inertia for different particles, right? Look at this question, try to solve it. There are two identical spheres, each of mass 2 kg. There are two identical spheres, each of mass 2 kg. 2 kg, 2 kg. They have a radius 50 centimeter, 50 centimeter, 50 centimeter, 2 kg and 50 centimeter. Okay, similarly 2 kg and 50 centimeter. All right, they are fixed at the ends of a light rod. They are fixed at the ends of a light rod. Okay, so that the separation between then centers is 150. The separation between the center is 150. This is the center. The whole thing is 150. This is 75 and this is 75. The whole thing is 150. All right. Then the moment of inertia of the system about an axis perpendicular to the rod and passing through the middle point about this axis, right? The moment of inertia about this axis is x by 20 kilogram meter square. What is the value of x, right? So about this axis, you have to calculate the moment of inertia of this thing, right? Again, the best question I could find on this one is this, right? There could be even better question than that, but if you solve this one as well, it will help you to revise lot of concepts in one single numerical, right? This is the motto of my entire lecture, right? To help you with the revision in the best possible way, right? And let me give you the option: 58, 53, 55, and 60. These are the options you have. And here you have the pole. All right. Here you have the pole. Sir, from where you can get the notes of the session? After the class, I will be sharing the notes of the session. And the link of those notes will be shared on the WhatsApp group as well. There is a WhatsApp group of this channel as well. You can get the notes from that as well, right? Nice. So, yeah, thank you, Sabha. All right, so I believe that is very, very clear. You think about the moment of inertia of the single sphere, you can calculate 2 by 5 mr square, right? About its own axis, you can know, right? But the moment of inertia about this sphere, about this axis, right? So parallel axis theorem comes into the picture, right? Moment of inertia about this axis, so 2 by 5 mr square I plus ma square, right? This distance, mass into this distance square, right? This is how you can figure out the moment of inertia of this one. Similarly, moment of inertia of that one can be added and the whole thing will be added to each other, right? I1 plus I2. Think about it, right? Let's see. Poll has stopped. And if anyone has given the correct option, let us see. Oh, Surya has given the correct answer. Triya has given the correct answer. Shreyanshi, Sanya, Kanva, Ananya, Veena, and Murslan. They have given the correct answer. Great. All right. So parallel axis theorem was involved in this one. And as I have already told you, just do simple thing. Right. About this particular body. So moment of inertia about this axis you have to find out. Its own moment of inertia about this axis and axis passing through the center is 2 by 5 mr square. And the axis here is 75 meters away. So it will be 2 by 5 mr square plus mr square. Right, and just multiply the whole thing by 2 because moment of inertia of this and the other one is same about this axis. So multiply it by 2 and you have the total moment of inertia. No problem with that. So it is 53 by 20. In the question it was given x upon 20 is the moment of inertia. So instead of x you have 53. 53 is the answer. Let's move on and talk about one more question. 4 particles each of mass 1 kilogram placed at the corner of a square of side 2 meters. Moment of inertia of the system about the axis perpendicular to the plane and passing through one of the vertices. Moment of inertia about one axis and passing through the vertices. Okay. So think about it. How can you figure that out? Very simple question, but again, based on the principle of perpendicular axis theorem, try to solve it and I'll give you the options as well, right? Simple questions, right? Try to solve it, right? Very nice. Okay. 4 particles. Chalo, this question I gave you as a homework, right? It is simply based on the previous question, right? And it should give you a very simple idea about that. Let us start with the concept of gravitation now, right? Gravitation concepts are, now from the gravitation, most of the questions in the NEET exam were based on 2 concepts, right? First is planetary motion and motion of spacecrafts, that is orbital velocity, escape velocity, right? And then variation in the value of g, right? Variation in the value of g, the questions were based on this topic and also the questions were asked from this topic, right? The third level, at the third level, questions were also asked from the concept of gravitational potential. Gravitational potential, right? These were the 3 topics they were asking repeatedly in the NEET exam from this particular chapter. And I have picked the questions from these topics for this particular session. Here is the first question, right? Okay. This formula is something you need to keep in your mind, right? So I'll give you the formulas in the notes, so no need to worry about that. Look at this particular question itself and try to solve it. Here is that. The gravitational potential at the point above the surface of Earth is this, right? The gravitational potential above the surface of Earth is used with a negative sign and they're giving you a negative value 5.17 into 10 to the power 7 joule per kilogram. The gravitational potential is given, right? Gm over r, right? The acceleration to gravity at that point is this. At that place, this is Earth. At this place, gravitational potential is this. And acceleration due to gravity is this, 6.4. Assume that mean radius of Earth is 64. Earth is not same. Earth is, flat at the ends. But let's say that the Earth is round and the mean radius of the Earth is 6400 kilometers, which is we always take. The height of this point for the surface of Earth is. So what they are giving you at this place, they are giving you the value of gravitational potential and they are also giving you the value of g at this place, right? So let's say that this distance is small r, right? This is the radius of Earth from here to here and this is h, right? So you have to find the height of this point from the surface of Earth. So h you have to find out, okay? Try to answer it and here is your 60 seconds starting now, right? Now if you answer, you can have your answer name in the leaderboard, right? All right. What is the formula for gravitational potential? It is minus, with a negative sign you can use it, minus gm over r. Gm over r, which is r plus r. So gm upon r plus h. That is the gravitational potential over here. What will be the formula for acceleration due to gravity at a certain height h from the surface? What is the formula for this small g at this place? You can say that in one numerical you are using two concepts, right? Which is why I have taken this one, right? So gm upon re plus h whole square. This is the value of small g at a height h, right? So just apply those concepts and try to solve it. Okay. So upon looking at this particular thing, so what is the result I can get? Okay. So let's see how many kids are giving the correct answer. Oh, everybody gave the correct answer. Shreyanshi gave the answer fastest, and then Kana, then Sanya, then Ananya, then Murslin. So these kids gave the correct answer. So let's see that. And you know, right, at this value, at this place, at certain height h, what is the value of gravitational potential? So the value of gravitational potential is minus gmu upon re plus h. This is the gravitational potential over there. It is given this value, right? And over here, the value of a small g is gme upon re plus h whole square. It is 6.4. So from these two, we can calculate the small h over here, 1600 kilometers. Okay. Look at this one. If capital V is the gravitational potential due to the sphere of uniform density on its surface, then the value at the center of the sphere will be very simple. Question from the gravitational potential, right? In the previous numerical itself, I told you the value of gravitational potential, right? What will be the value at the center of the sphere will be? So again, this numerical will also tell you something. So right now, I'm going to give you 45 seconds for this one. Simpler question, right? Those who know the formula for the gravitational potential at a distance r can easily calculate that. For a sphere, it is not a spherical shell, right? Gravitational potential due to a sphere of uniform density. It's a solid sphere, right? The gravitational potential depends on mass. Clearly, if you have solid sphere, this portion has lesser mass, this portion has more mass, this portion has more mass. So clearly, as you move away from the center, the gravitational potential rises, right? To at a distance small r away from the center. When you are at any random point away from the center in this situation, what will be the gravitational potential? This is the sphere of uniform density. This is the distance r. This is the point P. What will be the gravitational potential at point P? What is the value of gravitational potential at point P, right? The formula is very, very clear. It is gm over 2r cube 3r square minus a small r square, capital R, right? I'll tell you, right? Just first solve it, then I'll tell you, right? Let's see how many kids are giving the correct answer. Everybody gave the correct answer. Surya gave the answer fastest, then Veena, then Sanya, then Shreya, then Kanva, right? Then Ananya, then Priya. Okay. Nice, right? The kids have really, good level of preparation right now. It tells a lot about that. So you see that this is the general formula of gravitational potential from the center, right? So you see that put different values of small r, gm over 2r cube, 3r square minus r square, right? Gm over 2r cube, 3r square minus r square. This is the value of gravitational potential at a distance r from the center. So when you are at the surface, then r is equals to capital R. 3r square minus r square is 2r square, and 2r square, 2 and 2 will cancel out, r square and r cube will cancel out, and the r will remain. So gm over r is the value of potential at the surface, right? So value of gravitational potential at the surface is this, right? This formula is very, very important. Now let's find the gravitational potential at the center of the sphere. So at the center of the sphere, the distance is r is equals to 0. So put a small r is equals to 0 over here, right? So r is 0, gm into 3r square upon 2r cube, r square and this will cancel out. So it will become 3gm upon 2r. So 3gm upon 2r, this is the gravitational potential at the center, right? Gravitational potential at the surface, gravitational potential at the center. The ratio you have to figure out. The ratio will be very simple, right? Ratio of this and this you can figure out, right? It is 3v by 2. I believe the idea is very, very clear. Now the next set of questions are about acceleration due to gravity. You can easily do that as well. So let's have a look at that part, right? And you know that acceleration due to gravity at a height h, acceleration due to gravity at a depth d from the surface. These things are important. And now you can simply solve it. These are the formulas. Look at this question and try to apply the basic formulas and try to solve it. The question is saying that if r is the radius of the earth and acceleration due to gravity of the surface of the earth is pi square, then the length of the second pendulum at a height r h equals to 2r from the surface of the earth will be, what will be the value of length of the second pendulum, right? Think about it, right? In one single numerical you will have multiple concepts, right? Okay. So what will be the time period of the second pendulum? It is 2 seconds, right? Okay. So think about it. Look at that and you have your time over here, right? So try to answer it. Now if you have already, if you are trying to answer it, Sania, try to solve it. Okay. Very good. Kids are putting some effort, so that is very, very nice. All right. So here you have to talk about the length of the second pendulum at a height h equals to 2r. So what will happen? The time period is 2 pi under root L upon G. So length of the second pendulum, you see that for the second pendulum, what is constant? The time period is constant. It has to remain 2 seconds only. That is why it is second pendulum, right? Okay. Now, if T is constant, what is happening? At height, the value of G should change, right? Okay. And to keep the value of T is equals to 2 seconds, L has to be changing as well, right? You know that, right? So, r is the radius of earth and the acceleration due to gravity of the surface at the surface of the earth is this. Then the length of the second pendulum at h equals to 2r. So, at h equals to 2r, you will get another value of G. Put it over here. Put time is equals to 2 seconds. Calculate the value of L from here. Nothing really very serious about that one, right? Very simple, right? Okay, first of all, let's see how many kids have done it correctly. Okay, before moving forward, let's see how many kids have done it correctly. So everybody has done it correctly. And first of all, Veena has done it correctly. Then you have Sania, Ananya and Shreya. So let's see that. Okay, so here at a certain height h, so the value of G is G upon 1 plus h upon r, that is something there. So you can simply calculate, this is the new value of h, you can simply calculate that. For this new value of h, the time period is going to be 2 pi under root L upon G, right? You can put the values and from here you can calculate it further, no worries about that part, right? So at what distance above and below the surface of earth a body will have same weight? At what distance above the surface of earth and below the surface of earth the body will have same weight? Weight over here and weight over here should be same. So clearly weight depends on mass and G. Mass is same anywhere, right? So if the value of G is such that it is same over here and here, then the weight will come out to be same at both places as well, right? So try to answer it in the poll, right? Try to solve it. So G at a height should be same as G at the depth. So you need to know the two formulas and apply those two formulas simply and equate them. The value at which they come out to be same is your answer, right? Assume that at a height h and the depth h, right? That is the value that you're figuring out is h. At a height h and a depth h, it is same. And once you do that, you can figure out. All right. So let's see how many kids are giving the correct answer for this one, right? C. Okay. All right. So yeah, everybody has given the correct answer. So it's a very typical question that is, solved multiple times in multiple classes. So Shreyanshi has given the answer fastest. Then Surya, Veena, Sanya, and Moshain, and Kanva, and Ananya. These kids have given the correct answer. Now you see, right? How to look at that? So you see that the value at a point P at a height h, right? The value of G at a height h is this gr square upon r plus h whole square, right? And the value of G at a depth is G1 minus h upon r, right? So these things have to be same. So once you equate them, right, and you solve it, you will get the value of h, right? And that comes out to be this, right? So the answer is this. Now the next question is from the escape velocity, as I have told you, the motion of satellite, right? That is where the questions are generally asked from, right? This is second very, very important topic. So look at that. The mass of moon is 1 upon 144 times the mass of a planet, and its diameter is 1 upon 16 times the diameter of the planet. Okay, there is a planet. We are comparing the moon with that. The mass of moon is 1 upon 144 times of the planet. Diameter is 1 upon 16 times of the planet. If the escape velocity on the planet is v, the escape velocity on the moon will be, right? So what will be the escape velocity of moon compared to that planet, right? So very clearly we can answer it, right? Look at the formula for escape velocity, right? Under root 2 gm upon r. So it depends upon mass and radius of the planet, right? Look at this formula, apply this formula and try to solve it. So here you have it. Try to solve this particular question, right? So escape velocity is root 2 gm upon r, right? What will be the escape velocity on the moon? Once you know the escape velocity on the planet was v, right? For the moon, the mass is 1/44 times, 1 upon 144 times, and the diameter is 1 upon 16 times, right? Very simple question, and it should be able to, everybody should be able to solve it. V by 4, V by 6, V by 12, V by 3. These are the options. Nice. Very good. So let us see how many kids are giving the correct answer now. Some kids are trying and some kids are giving the correct answer. So let's see that. Shreyanshi has given the fastest answer, then Sanya, then Veena, Mushlin, and Kanna, and Ananya. So yeah, let's see. So here we have it. So clearly escape velocity is root 2 gm upon r. For the moon, mass is 1 upon 144 times. So instead of mass, you have this. And radius is r by 16. So r by 16 is going up, right? So this is the escape velocity on the moon. It is, when you take the common, 1 upon root 3, this is root 2 gm upon r, which is the escape velocity on the planet, right? So instead of this part, you can put v. So it is v by 3. That is the answer. Simple. Now look at this question. Escape velocity of a body from the earth is 11.2. If the escape velocity of the planet be 1/3 of the radius of earth and mass is 1/6 of radius of earth, what will be the escape velocity of the from that particular planet will be? The radius of the planet is 1/3 of earth, mass is 1/6 of earth, escape velocity you have to figure out, right? Very simple, you can do that, right? Based on the last numerical, you should be able to do that much quicker. Try to solve it, and I believe everybody should be able to solve it right now. Okay, very quickly you can solve it. Good. Surya saying that one kid is me. Nice. Try to solve it. Escape velocity of a body from the earth is 11.2. If the radius of planet is 1/3, mass is 1/6, escape velocity from the planet is root 2 gm upon r. That's the idea, right? And for the earth, it is 11.2 kilometers per second. It is a standard value, right? And what should be the correct value? Let's see how many kids are giving the correct answer. Everybody is giving the correct answer. Let's see. Priyanshi gave the answer fastest, then Ananya, then Sanya, and then Veena, then Muslim. And yeah. So let's see how to solve it. So clearly the idea is similar to the previous one, right? So root 2 gm upon Re, right? This is the escape velocity of Earth, 11.2, that is given already. For the planet, mass of planet is 1/6 of mass of Earth. To do that, and for the radius of Earth, radius of planet is 1/3 of radius of Earth. So to do that, right? Once you do, velocity of escape velocity of Earth and planet will be root 2, right? And simply escape velocity of Earth put 11.2 and the ratio comes out to be 7.9. Yeah. So here you have it, orbital velocity, right? The velocity at which a body will orbit around a certain heavier mass, which let's say it is Earth or planet, right? And it will maintain that particular velocity while moving at that particular orbit, right? So the orbital velocity is root 2 gm upon r, right? Okay. Look at this question, try to solve it. The spaceship of mass this much is launched into a circular orbit close to the Earth's surface. The additional velocity to be imparted to the spaceship in the orbit to overcome the gravitational pull will be, right? Think about it. Right now, this is the Earth, this is the body. Right now, it is moving with orbital velocity around Earth. It has certain kinetic energy, right? And it is bounded with gravitational force of Earth. If you provide it enough energy so that its total energy becomes half mve square, escape velocity, it can escape and it will never come back, right? So what do we want? How much more kinetic energy we should add to it so that it becomes high enough and it leaves the orbit altogether and it never comes back in that same orbit. So it basically escapes from it, right? So this is something you have to answer. To try to answer it. All right. What will be the new escape velocity in this situation? What will be the new escape velocity in this situation? All right. Very nice. Shreyanshi is giving the answer. So Sanya is giving the answer. Very nice. Let's see that how many kids are giving the correct answer in this one. Let's see. Right, the time is up and now we can look at this particular value. Let's see who has given the correct answer. So yeah, surprisingly, here Murslen has given the correct answer, and then we have Ananya, Veena, Surya, Kanva, Shreya, and Shubhaib. Okay, nice, great. So the idea is very, very clear, right? So when a body is moving in a certain orbit, it has limited amount of energy, right? Body can escape the gravitational force of a planet only when it has escape velocity. So the total energy should have is half mve square, right? So the difference of that, if you have to provide, then it will simply move away, right? So here you have orbital velocity root gm upon r. So this is the velocity when it is rotating in that certain orbit, right? So orbital velocity you can calculate, right? It is 8 into 10 to the power 3 meter per second, and escape velocity is root 2 times orbital velocity, right? So what is the difference? Root 2 minus 1. So here it is. This is the difference of velocity you have provided, right? So now based on that, you can simply tell that this is the difference. If you can provide that much velocity extra, then the particle velocity will be equal to the escape velocity and it will simply leave the planet altogether. Look at this one. Two satellites of masses m and 3m revolve around the Earth in circular orbits of radii r and 3r. The ratio of orbital speeds of the satellites respectively will be. Simple question, right? Try to solve it. Okay. Try to solve it. Here we have two satellites, right? Poll detected your answer late, so no worries. Okay, once I open up the poll, you can answer you can have the answer multiple times, right? So just put A, B, 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 whatever your answer is. So make sure the poll detects your answer, right? I believe the idea is very, very clear, right? Again, a very simple numerical. There are two satellites. They have circular orbits in radii r and 3r. Every orbit of radii r has a certain orbital velocity, root gm upon r. So the orbital ratio will be a very easy to find, root gm upon r for the first one, root gm upon r for the second one. So v1 upon v2 will be root r2 upon r1. Clear? So you can even solve it without even picking your pen. Okay, let's see. Everybody gave the correct answer as expected, and Shreyanshi was the first one to answer. Okay, so now there was nothing serious about this question, right? So the thing is, will orbital velocity is root gm upon r. So for v1 and v2, root gm upon r for the first one, root gm upon r1 for the first one, and root gm upon r2 for the second one, right? This and this is cancelling out. It is root r2 by r1, right? So clearly you can put the value of r2, it is 3r, and here it is r1, so root 3 by 1 is the answer. Let's move on and talk about the next one. This one is properties of solids and liquids. So let's have a look at that one as well. So here you have it. So you see that here you have a body, you apply some forces on it, right? The body tries to elongate, and in that situation there are certain values. The stress and strain are created in this situation. The stress is force per unit area in this situation, and strain is that change in length upon original length, right? These formulas are there for your revision purposes. You can apply those formulas in this numerical and try to solve it. With rise in temperature, what will happen to Young's modulus of elasticity? Look at that and try to answer. Simple memory based question, simple logic based question, right? Right. Try to solve it. What will happen with the rise in temperature? The rise in temperature, what will happen to Young's modulus of elasticity? Young's modulus of elasticity tells you the ratio of stress and strain, longitudinal stress and longitudinal strain, right? So what will happen? Once you increase the temperature, you will get more strain, more deformation easily for a given force. Think about it. You increase the temperature, for a same force, deforming will be easier, right? So stress upon strain, higher value of strain for the same value of stresses, right? So clearly denominator is increasing, so the value of Young's modulus will reduce, right? So let's see that who is giving the correct answer. Everybody not giving the correct answer. Shreyanshi gave the correct answer only, right? So as you can see, it will decrease, right? With increase in temperature, the Young's modulus of elasticity will decrease, right? And you see that it is common sense. Young's modulus of elasticity is a stress over strain. What is a strain? Change in length upon original length, right? Okay. You have a body and you apply forces on it and it increases, right? Let's say the length of this body increased by this value, right? So this is the change in length. This was the original length, right? So clearly when you increase the temperature, once you heat up the iron rod, deforming it becomes easier, no, right? So strain will be higher. The denominator is rising with increasing temperature, right? So y is reducing with temperature. Young's modulus is reducing with temperature. I believe that is very, very clear. All right. Look at this question. A wire of length L, radius R is clamped at one end. If the other end is pulled by force F, its length increases by L. If the radius of the wire and the applied force are reduced to half to their original values, keeping the original length constant, right? What is happening? Radius of the wire and the applied force both are reduced to half. Radius is reduced to half and the force applied is also reduced to half, right? Okay. Keeping the original length constant. Length is constant. Okay, so original length was L. After the change, the length is still L. Previously the radius was R, now for the new wire radius is R by 2. Previously the deforming force was F, now it is F by 2. Previously the length was L, now the length is still L. Okay. What will be the change in length in this situation? So here in the first case, the change in length was delta L. What will be the change in length in this situation? Delta L2, let's say, right? So clearly you can easily tell that, right? You are not changing the material of the wire, you are not changing the temperature in this situation. So what will remain same? In both the cases, the Young's modulus will remain same. So Y1 and Y2 in both situations will be same, right? So clearly, Y is stress upon strain. Stress is this, strain is this, right? So it is FL upon A delta L, right? Yes or no? So clearly the Y1 and Y2 are going to be same. FL upon A delta L for the first one, FL upon A delta 2 for the second one, keep them same, and from there you can get the ratio of delta L1 upon delta L2. Very simple numerical, and you should be able to solve it in 30 seconds. Try to solve it. All right, very good. Kids who solve the problem are the best kids. Very nice, Shreyanshi, Jaya, nice. Keep solving the problems so that the problems don't become a problem for you. All right. So by doing this, I got motivated in physics. Crazy, Shreyanshi. Right. So just if you're just solving some good problems, that is way better than solving just some PYQs randomly. All right. So let's see how many kids are giving the correct option. So yeah, some kids are trying and some kids are giving the correct option. Nice. Murslin, Kanva, Surya, Shreyanshi, and Sanya, they are giving the correct answer. Right. So clearly, just you know, the pattern I have already told you and the concept I have already told you. Right. What will happen? In this situation, Y is a stress upon a strain, and from here you can get the value of Y like this. Right. So what is happening? The value of force is this, right? And just put the new parameters. The force is reduced to half, and the radius is also reduced to half. So the area is pi r square by 4 now, right? So now you can get the same values like this, right? And from those two equations, just equate y and y1 and y2, and you can easily calculate that, right? Right. So yeah. Bulk modulus is when the deformation is happening across the volume, right? So applied pressure upon change in volume, right? Look at this question and try to solve it. If the average depth of ocean is 4000 meters and the bulk modulus of water is 2 into the power 9 Newton per meter square, the fractional compression delta V upon V of the water at the bottom of the ocean is this. What is the value of alpha, right? What will be the value of alpha? I'll give you certain options and you can choose one of those options, right? All right. What will be the value of alpha? The answer is coming out to be alpha into 10 to the power minus 2. Let's say the option A is 2, option B is 3, option C is 4, and option D is 5. This is for you to answer now, and you can take 45 seconds and answer it, right? So the depth of the ocean is given, right? And based on that, you have to calculate it. The depth of the ocean helps you to figure out what will be the value of pressure over there, rho GH, okay? Rho GH. The bulk modulus is simply hydrostatic stress, which is pressure, upon change in volume, delta V upon V, right? You need to find out this part only. So delta V upon V will be delta P upon B, right? So you see that delta P will be rho GH, and B is already given. Bulk modulus is 2 to the power 9. So B is given and delta P is rho GH. Delta V upon V can be figured out. Very simple. Right. So I believe the idea is very, very clear. And if you have any questions regarding this, you can definitely ask me. So let's see. Oh, everybody gave the correct answer. Simple numerical was there. Surya, Shreya, Ananya, Shoaib, Jaya, Kanwa, Srina, Muslin, everybody gave the correct answer. So yeah. So option A is correct. So let's see. So clearly delta P upon delta V, and we have to find out delta V upon V part. So it is simply delta P rho GH, and B is simply given in the question, right? Divide it and you have the answer. Okay, so this is similar question and similar type of answer should be there. Now you see you have this equation of continuity type of question, try to solve it. The previous question you can solve it as a homework, simple one. Look at this one, equation of continuity based on this particular concept. You have this particular question. A plane is in a level, so it's a good question by the way, right? This question is good. Look at this one and try to solve it. A plane is in a level flight at a constant speed, and each of the two wings has a area of 40. If the speed of the air is 180 over the lower wing surface and 252 over the upper wing surface, okay, the mass of the plane is, so you know that once you look at the plane, let's say that this is the plane. All right, this is the wing. So the plane is moving up and plane can leave the ground. Why? Because there is a net upward force that acts on it, right? So why is that happening? The air above the wing of the plane is moving like this, and air below the plane is moving like this, right? And you know that the place where the velocity is higher, the pressure will drop at that place. If above the wing velocity of the air is higher, so pressure above the wing is lesser, right? And if velocity of the air below the plane wing is lesser, that means the pressure is higher, right? From the Bernoulli's principle, right? So here you have higher pressure, here you have lesser pressure, right? So pressure into area is the total force, right? So clearly you can say that there is a net upward force that is going to act in this way, and that will be called as lift. That is lift on a single wing, right? So lift on a single wing is difference of pressure into area. That is lift on a single wing. If you multiply that lift by 2, you have the lift on both the wings, right? Clear? So yeah, you just multiply that. You see that speed of air is 180 over the lower wing, lower side of the wing. So it is 180 lower and 252 above, right? So clearly above pressure is lesser, here pressure is higher, which is why it is creating the lift, right? So now just apply the Bernoulli's principle, right? And upon the application of Bernoulli's principle, get the value of pressure differences, right? And solve it. Okay. So here you have it. These are the options: 9600, 10,000, 15,000. What is the weight of this thing? Okay. Try to solve it. Right. You can consider there is no change in the gravitational potential energy. So Bernoulli's principle, you can say that pressure and half rho v square. Okay. This is pressure head, and this is pressure and energy associated with the pressure, and energy associated with the velocities. They are going to be the constant, right? So P1 plus half rho V1 square is equals to P2 plus half rho V2 square. So P1 minus P2 can be figured out. Half rho V2 square minus half rho V1 square. So once you know the pressure difference delta P, P2 minus P1, you can multiply that by area of the wing. You can get the lift generated on a single wing. Multiply that lift by 2. You have the total lift generated on the entire plane, right? And that is given, right? Very nice. Okay. So let's see that how many kids are giving the correct answer. Oh, how come everybody gives the correct answer for these kind of questions? Nice. So Shreyanshi is giving the correct answer. Sanya, Kanvas, Shravan, Surya, they are all giving the correct answer. Ananya, Muslan, everybody is giving the correct answer. Nice. So the idea is simple, right? You just need to equate these two things, right? And upon doing so, you get the values of pressures, right? And you can get the difference of pressure from here, right? It is half rho V2 square minus half rho V1 square. V1, V2 are given already. They are giving in kilometer per hour. Convert that into meter per second by multiplying it by 1000 by 3600 or 5 by 18, right? 50 and 70 is the speeds, okay? So just multiply that, and rho is 1 kilogram per meter cube. It is density of air, right? So delta P is given as this much, okay? So once you know the value of pressure difference, multiply that pressure difference with area, you have the lift on a single wing. Multiply that by 2, lift on the total wing, which is this, right? 96,000 Newton. Multiply the net force by G, that is going to give you the mass, right? Lift by G is going to be the mass, right? Now look at this question. Glycerine of density this much is flowing through the conical section of pipe, okay? There is a conical section of pipe. Glycerine is flowing through it. The cross-sectional area of the pipe at the ends is 10 and 5. So here you have 10 square centimeter. Here you have 5 square centimeter. And the pressure drops across the length by 3. So P2 minus P1 is 3. Right? Where the pressure will be higher? Here the velocity will be higher. Pressure will be lower. So the pressure difference is 3. Pressure drops is 3. Okay? The pressure drop is 3. Clearly the velocity will be higher here. So pressure will be lower. So pressure drops by 3 units, 3 Newton per meter square, or 3 pascals. The rate of flow of glycerine through the pipe is this. What is the value of X? Right. The rate of flow of glycerine through the pipe is X. What is the value of X? Right. Tanya is saying feeling so good today. That because she can solve a lot of questions about that, right? And she can solve some good questions, right? In this class, I have not picked very simple questions. In fact, I have picked a lot of questions from previous year JEE mains exam, right? So if you guys can solve all those questions without a problem, you should be able to you should be confident about your level of preparation, because what I have done is very simple, right? I looked at the pattern, right? These kind of questions are asked. This is the topic where the questions are asked from the NEET exam. And based on that, I picked some really good questions. From the NEET previous year question, if I could not find good questions, I picked from those topics questions from the JEE mains. Generally, they do that. They pick questions from JEE main and they keep the topic what they usually do for the NEET exam, right? So I did the same for you, right? So you can answer it. All right. So did I started the poll for this one? No? Okay. So have a 30-second poll for this one. Please answer it once again in the poll section. I forgot to keep the poll in it in this one, right? Okay, just answer it one more time in the chat section, right? So that this poll can record your answers and put it over here. Yeah, Shravan. Thank you. Great. So I believe the idea is very, very clear, right? These kind of questions should be giving you decent, confidence once you start solving them regularly, right? So let's see how many kids gave the correct answer. Oh, everybody gave the correct answer. Muslain was the first one. Then we have the Sania. Then we have Ananya, Kanva, and Shreyanshi. So good. So option is B, 4. Let's see that, how to solve it. So clearly, in this situation, we have the change of area, but to know the values of velocities, how the velocities change across the conical section, right? You know the area over here and area over here because the diameters are given, right? So A1, V1 and A2, V2 are going to be same. This is a continuity equation, right? And by applying the Bernoulli's, you can also get the pressure difference, which is given as 3, right? So by looking at these two things, you can easily calculate the density of this particular thing, right? You know that difference of pressure P2 minus P1 is 3. The pressure drop is 3, right? And by looking into this equation, V1 and EV2 can be also calculated because A1, A2 are given. So here, the density of the liquid is this. And once you know the value of density of the liquid, you can get the flow rate. The flow rate is A into V. You can just put the values and get the value of flow rate. Okay. All right. Stokes law. So this is it. Right. Viscosity and all. So look at this question and try to solve it. A small spherical ball of radius r falling through a viscous medium of negligible density has a terminal velocity v. Another ball of same mass but radius twice of r falling through the same viscous medium will have terminal velocity how much? You know that when a ball of radius r is falling through a viscous medium, right, it will have certain opposition, right? It will have certain opposition, right? And due to that opposition, what will happen? The downward weight is acting upward, the drag force is acting in the opposite direction, the downward force is weight is acting downwards, and the upward force is what? Drag force due to viscosity. And you know that the drag force increases with velocity of the body. So as the body gets faster, the drag force also increases. There is a point at which the drag force and the downward force become same. At that point, there is no net force on the body and the body falls at a constant speed. You call that as terminal velocity, right? You know that, right? And the value of terminal velocity is root 2 mg upon c into a into rho. Okay. So look at that. A small ball is this and doing all that, right? You have to find about this thing. So let me start the poll and then keep telling you the concept meanwhile, right? Okay. So try to solve it. So what will happen? At terminal velocity, the downward force and the drag force, they are same. That is mg and the drag force is 6 pi into rv. That comes out to be the same, right? And we know that the terminal velocity and the radius of the ball, they are opposite to each other, right? From the formula, right? I believe the ideas are very, very clear, right? So let's see that how many kids are giving the correct answer. Oh, all of you are correct. Kanva is first, then Surya, then Shravan, then Yogesh, Ananya, Shreyanshi, Murslan. All right. So let's see, V by 2 is correct. All right. So how is that happening? Because at the terminal velocity, there is no net force, which is why weight is being balanced by the upward drag force. Mg is the weight, upward drag force is 6 pi into rv. They are being balanced with each other at the terminal velocity. And we know that the terminal velocity is opposite, inversely related with the radius of the ball, right? So if the radius is doubled, what will happen to the velocity? You see that it will be halved. Question is saying the air bubble of a diameter 6 mm rises steadily through the solution density 1750 kilogram per meter cube at a rate of 0.35 centimeter per second. The coefficient of viscosity of the solution is. So this is something you have to figure out, right? What will be the coefficient of viscosity of this particular situation, right? So yeah, for this one, here you have this thing from the Stokes equation, you can figure that out. That is something I can give you as a homework. From the surface energy concept, we can take a couple of questions as well. Let's take one question from the surface energy concept. That is interesting, right? So here you see that if you know the surface tension and you can calculate the surface energy as well, surface tension multiplied by the area is the energy associated with the surface, call it surface energy, right? Surface tension multiplied by the area is the surface energy associated with the body, right? So look at that, a big drop is formed by coalescing 1000 small droplets of water. So you have 1000 small droplets, you join them and you make one big drop. So there will be a relation between the radii. The radii of this droplet is a small r, this is small ones, and the radii of this bigger one is capital R. A small r and capital R can be related. How? 1000 times the volume occupied by each one of them is the total volume of this one, right? 1000 balls or small balls are mixing up and giving you one bigger one, right? So one ball has a volume 4 by 3 pi r cube, 1000 times give you this much, right? So you can get a relation between a small r and capital R, right? The surface energy will become, so once you know the value of surface tension, right, you can easily calculate the surface energy as well, right? And you know that the surface energy is related to the surface area in a certain way, right? I just told you the formula for that, and based on that formula you can easily solve it. Very simple question. If you understand the basic formula really well, right, you can solve it. All right. So just surface tension is multiplied by area gives you the surface energy, right? By coalescing 1000 balls, you have a newer, bigger ball that has a certain radius. You can easily calculate that. Once you know the radii of newer ball, you know that area of a sphere is 4 pi r square. You can calculate everything else. Oh, oh. All right. So let's see that who is giving the correct answer, right? Okay. The fastest answer was again given by Shreya here. And then we have Sanya, Smurslain, Kanva and Shravan. Okay. Let's see that if you kids can solve the grade 12th question with the same speed as well or not. Let's see. First of all, over here we can say when 1000 surface tension is simply surface energy is surface tension into area, which this is a basic formula, we know that, right? So you know that for a smaller the smaller 1000 droplets are mixed together to form a bigger one. A smaller one has a radius, let's say small r. So each small droplet has volume 4 by 3 pi r cube. 1000 of these has 1000 times this. That should be equals to 1000 times 4 by 3 pi r cube. If the bigger one has a radius capital R, so the bigger one has volume 4 by 3 pi capital R cube. They should become equal. They should become equal. And here you have a radius relation between the radii. Clearly, you can also get the relation between the surface area 4 pi r square, right? So the relation between the surface energy is going to be E1 upon E2. So pi surface tension into area 1 square, area 1 upon surface tension into area 2. So it is simply the ratio of areas. You can easily get that. It is 1 into 10, right? All right. So the similar concept is this. You can solve that as a homework now. And now you can move ahead and talk about this one. All right. So you know that because of the air pressures, right, because of the surface tension, when you have an air bubble, there is a pressure difference between inside and outside of that air bubble, right? You have to talk about that. The small liquid drop of radius r is divided into 27 liquid droplets. Same thing happens, pressure difference happens in the liquid droplets as well, right? Just that here you in the liquid droplet you have single surface, in the bubble you have two surfaces, right? So a small liquid drop of radius r is divided into 27 identical liquid drops. If the surface tension is T, then the work done by the process will be. So a bigger drop is divided into 27 small droplets. So what will be the value of work done in this situation? So we can say that, how to calculate it? Yeah, Surya. So of course, that is why everybody will learn something from each question, right? If everybody knows everything, then you can give the correct answer all the times, but no problem, right? So try to answer it. You have your 45 seconds for this one, right? This question is good. Try to solve it. Again, the concept is same. If the same droplets are added or removed, the total volume occupied is same. So if the bigger droplet has a radius capital R, small droplets that are formed newly has a radius small r. So total volume of 27 small drops is same as one bigger drop. So 4 by 3 pi capital R cube should be same as 27 times 4 by 3 pi small r cube. So from here you can get the relation between capital R and small r, right? And work done is the difference of surface energy. How much work is done? It is the difference of surface energy which is created, right? Surface energy in the final case is T into A2. Surface energy initially is T into A1. Difference of that is that surface tension is given T already, right? Difference of surface energy that you bring upon is the value of work done, right? How much work is done in this case? Let's see. So Sania has given the correct answer. Then we have Shravan, Shreyanshi, Ananya, right? And then we have Zoro. All right. So let's see that how to solve it. So again, first of all, you have to find the relation between the radii, right? Relation between the radii. So 4 by 3 pi r cube is same as 27 times this one. So small r and capital R can be related in this way. So what will be the value of work done? T into delta A. From that, you can easily calculate this. Okay. Look at this one. The same thing you can do in this one as well. Here you have a bubble in place of this thing. So no worries about that. You can solve the same. Similar question is there. This question can be solved as a homework. Similar question is there, right? Now let's move ahead and talk about some questions from kinematics, kinetics of gases, right? And thermodynamics, right? So let's look at that thermodynamics part. Okay. So some basic formulas are there, right? Look at that. A gas mixture consists of 8 moles of argon, 6 mole of oxygen at temperature T, neglecting all vibrational modes. The total internal energy of the system is, what will be the total internal energy of the system? Try to answer it. Right. What will be the total internal energy of the system? Right. Think about it. Here you have to think about if I'm using a diatomic gas, a monatomic gas, or all that. Right. Argon is inert gas. For this, it is 3 by 2 K, 3 by 2 RT. For oxygen, it is diatomic gas. It is going to be 5 by 2 RT. Right. All right. Let's see. All right. So Surya was the first one in this one. Then we have Sanya and Zoro and then Shreyanshi. So let's see. So here we have it. Here we have it. A gas mixture consists of 8 moles of argon. So simply we can say that argon is an inert gas, right? So argon is an inert gas. So that is why its energy associated with that are basically 3 by 2 RT into number of moles here. So we have argon 8 moles. So for total, for 1 mole, it is 3 by 2 RT. For 8 moles, it is 8 into 3 by 2 RT. For oxygen, it is 5 by 2 RT for 1 mole. So for 6 mole, it is 6 into 5 by 2 RT, right? So neglecting all vibrational mode, the total internal energy of the system is. So we can just add that up and get the total energy of the system. So 8 into 3 by 2 RT for argon, 6 into 5 by 2 RT for oxygen. Just add them up and you get the total internal energy of the system, right? You have this much heated air, that is constant volume, 5 degrees centigrade. The specific heat of air is this, right? The change in its internal energy is approximately what, right? What will be the change in the internal energy, right? Look at the question, try to solve it. A gas is heated. So once you heat, right, what will happen at a constant volume? If you are going to heat it up, all the energy is basically going into increasing the internal energy of the system, right? All the energy is basically going into changing the internal energy of the system. And how to find that? So you know that at constant volume, right, change of internal energy is mCV dt, right? At constant volume, change of internal energy is mCV dt. So if you can easily solve it, the specific heat of air at a constant volume is 0.17, right? A specific heat at a constant volume, CV is given 0.17, right? So J is given as 4.1 joules per calorie. Yeah, the change in the internal energy is approximately how much? If that much air is heated, mass is given as well, right? Okay, heated by 5 degree. So delta T is also given, mass is given 0.08, CV is also given this much. So just multiply that and you can get the value of delta U. You can answer that in the poll now, right? Everything I have told you, right? All the parameters are already given. Make sure CV is given in calorie per kilogram per degree centigrade. In this formula, if you want the change of energy in joule, you have to convert the calorie into joule first, right? Do that. Otherwise, your answer will not be in joules. Your answer will be in calories. Right. Okay. Nice. So let's see who is giving the correct answer. So some kids are trying and some kids are giving the correct answer. And Kanva, Zoro, Sweb, which is Sanya, and Kananya, and this kid, Shreyanshi and Shravan, they are all giving the correct answer. Shravan is also there. So let's see that how to solve it. So as I already told you that you just have in this numerical, there was only one thing. You need to convert this kilocalorie by multiplying that by 4.18. That is why they are giving you the value of J. In the question, if they were not giving you the value of J, if J is 4.18 anyway, right? You can multiply that with this one and you can get the value of CV in joules as well, right? So this is it. Just put all the values, everything is given. You just put the values and multiply that. CV is given this. All right. So from kilocalorie, just multiply that, right? 4.18, you can convert it into it, and then delta U can be figured out 284. Right. Now, thermal processes are there, right? It could be isothermal process, it could be adiabatic process, right? It could be polytropic process and all, right? But in your syllabus, generally isothermal and adiabatic are asked, right? So for isothermal process, these equations are valid. And for adiabatic process, other equations are valid as well. Look at this question and try to solve it. The pressure P1 and density D1 of diatomic gas 7/5 is the gamma for that. It changes to P2, right? Pressure is changing to a pressure P2 and density D2, okay? During an adiabatic process, the temperature of gas increases and becomes that many times of its initial temperature, okay? So you have to answer, right? So you have to answer that the temperature of the gas will increase and it becomes some times of the initial temperature. So try to solve it, right? So we are dealing with the adiabatic process right now, right? We are dealing with the adiabatic process right now, right? So if you think about it, there is a certain equation which is followed in the process of adiabatic process, right? So how many times the temperature will become? It is 5 times, 3 times, 7 times, 4 times. These are the options. And for the adiabatic process, the equation is same, right? Like PV to the power gamma, gamma is the adiabatic constant, PV to the power gamma, that remains the constant, right? So the gamma is given 7/5 for this one. For this adiabatic process, 7/5 is same, right? Options are these 5, 3, 7, 4. All right. All right. So P1 V1 to the power gamma is same as P2 V2 to the power gamma. That should be same, right? For the adiabatic process. Here we have to know the ratio of temperatures, right? All right. So let's see that how many kids are giving the correct answer. Oh, simple numerical. So Surya was the fastest one, then Zoro. Then we have Shreyanshi, Subhay, Sanya, Ananya, Kanva, and then Shravan. Okay, good. So let's see that. So in this one, this is the equation for the adiabatic process. P1 to the power gamma is same as P2 to the power gamma, right? So you can rearrange it in this form and you can further solve it to get the values of T2, which is come out to be 4 times C1. So I'm not going to put so much time into this one. So look at this one. So what is happening? In an isothermal change, the change in the pressure and the volume of the gas can be represented by which of the following graphs? So this is simply an observation kind of problem. Look at that and try to solve it. So we can simply answer it based on the idea that how does a graph look like for a certain process, right? So look at that. Isothermal change is happening, right? So T3 is more than T2 than in C1, right? So isothermal graph doesn't look like these two. So it should be in these two only. So here you have T1, T2, T3. Here you have T1, T2, T3, right? T1, T2, T3, and here you have T1, T2, T3, right? So which one should be correct based on the temperatures. It is given T3 is highest. Simple one. All right. A. All right, let's see, right? Poll is stopped. So let's see which one is correct. Option B should be correct. Oh, so we have a very equal distribution across these things, right? And Khanwa this time was correct in this one, right? So yeah, let's see what should be the correct answer in this situation. So clearly these two graphs are not for the isothermal processes, and here it is written T3 is the highest one. So clearly if you look at that, PV is nRT, right? So these two values must be on the higher side for a higher temperature. So this graph is for the highest temperature, then lesser temperature, right? So clearly B is the correct answer, right? Yeah, right. T3 is highest. Then you have some questions from kinetic theory of gases. Look at this one. The temperature of gas is this. The temperature of gas having these many molecules per cubic meter at that kind of pressure is. So simple numerical is there. Direct formula based numerical is there. Try to solve it, and let me give you the poll first, right? And meanwhile, when you are solving it, I will explain you the concept of this particular numerical as well. All right, so keep solving it. All right, so for any ideal gas, the temperature of the gas is this. The temperature of the gas we have to find out, that many molecules per cubic meter, and pressure is also given 1.38, right? So we know that PV is equals to nRT, right? And now they are not giving us the number of moles, they are giving us the total number of molecules. So if you look at that, PV is equals to nRT. So how do you find that? Total number of molecules upon Avogadro number, right? That's how you do it, right? So n upon this RT, right? And they are giving you the value of K. So in terms of K, you want to solve it. So PV is equals to this. So how will you convert that in terms of K? So you see that V can be taken on the other side. So let me do it in this step itself. So those kids who can do it, they should be doing it itself. V will be going on this side. So look at this part. It is telling you something, right? R upon, no, not the whole thing. Oh. This one, N upon Na, RT and V. So this part is telling us something, right? Just solve it. R upon Na will become K. So this has become K upon V. So it is going to be R upon Na upon R is K, right? So it is 1 upon K. Yeah. So it will become N upon N times K. No. Right. It will become N K T upon V. Right. Yeah, I believe this is correct. So R upon Na is going to be K. R upon Na is going to be K. Yeah, this is correct. Okay. So this is how we will get the equation. Right. Now the equation is in terms of a constant. Total number of molecule they are giving. Now the N is total number of molecule. K is Boltzmann constant and T is temperature. V is the volume. Right. Now the given question is in the terms or the parameters that are going to favor us. Okay. This seems good. Right. Now let's look at that. How many kids are giving the correct answer? Yeah, some kids are giving wrong, some kids are giving right. No problem with that. Shreyanshi has given the fastest answer, then Shravan, then we have Sanya, then we have Kanva, then we have Zoro. Okay, let's look at that. So this equation we need to work upon, right? This is the equation we need to work upon, right? So if you just apply with this thing, you will have this thing, pressure in terms of Boltzmann constant and this thing. So here the benefit is n is the total number of available molecules, which is given in the question, right? And all other parameters are also there. Pressure is given, n is given, v is given, k is given, everything else is given. T is something we have to figure out, which is 500 Kelvin. Yeah, right. Now let's move on and talk about one more idea. All right. Now let's move on and talk about one more idea, which is going to be slightly more, demanding. All right. So in the oscillations and wave we are, and after that the grade 11th portion of the session will be over, and then we will jump onto the grade 12th portion. I believe grade 12th portion will be much fresh in your minds, and you should be able to solve it much quicker as well, right? So oscillations and waves are there. So let's look at that. So these are the equations related to the particle performing SHM, right? And there are certain parameters, right? I believe these things you know, and if you don't know or don't remember that, download the notes and you can revise it, right? Look into this question and try to solve it. A particle executes simple harmonic motion with an amplitude of 4. At the mean position, velocity of the particle is 10. The distance of the particle from the mean position when its speed becomes 5 is root alpha. What is alpha? So you know that. What is the expression of velocity at a distance x from the center when it is performing SHM? Right? Think about it and try to solve it. Right? Take your time and try to solve it. I'll give you the options and everything. Okay. All right. A particle which is performing SHM at any position, let's say it is at a distance x from the mean position, right? What will be the velocity at that random position over here? It is omega under root a square minus x square, right? So by thinking about that particular part, we can solve it. We will get certain value of velocity. It will come out, let's say root 50. So alpha will become 50. Compare it with that, right? So think about it, and so I try to solve it. Options I will give you, and then I will start the poll. So A, B, C, D, these are the options, right? And the value of alpha is 16, 18, 12 and 22. All right. So try to solve it, and this thing is very easy, right? A particle is performing SHM with an amplitude A of 4 centimeter. So convert that. Velocity of the particle, everything is given in centimeters, so don't need to convert. A is given. The velocity of the particle is 10 centimeter per second. Velocity of the particle is 10 centimeter per second. Right, where? At mean position, right? The distance of the particle from the mean position where its speed is 5 centimeter per second is, let's say at x, the velocity becomes 5 centimeter per second, right? What is the value of alpha? So V is equals to omega under root a square minus x square. The final value of velocity becomes 5, right? This is the maximum velocity. Let's call it V naught. This is velocity at x. So velocity at x is omega under root a square minus x square. So velocity at x is given 5, right? A is given, right? And x we have to find out. Okay. All right. And they are giving you the velocity at the mean position. V is equals to a omega, V naught is equals to a omega, we know that, right? A is 4, omega we don't know, and V naught is given as 10 centimeter per second. So from here omega can be figured out 5 by 2, put omega is 5 by 2, right? So everything is given, A is given 4, omega is given 5 by 2, x can be figured out very easily, right? All right. So I believe the idea is very, very clear. Okay. So now we can look at who has done the question correctly. So yeah, everybody has done the question correctly. Good. Surya has done it first, then Shravan, then Kanva, then Divya, then Ananya, then Sanya, and then Shoaib. Good. So let's look at the question after that. Okay, so here you have it. So this is V is equals to omega under A square minus S square. Just put the values and get the answer. So very simple kind of question. These kind of questions are expected in NEET itself, right? Again, very simple question. Just solve it on the previous grounds as well. So particle perform SHM with amplitude A. Its speed is increased 3 times at an instant when its displacement is 2a by 3. The new amplitude is na by 3. What is the value of n? Similar kind of approach can be used and solve this one. This can easily become your homework problem, right? Similar kind of approach can be used, omega under root a square minus x square, and can be solved this one, right? So now look at this question. It's a spring block system. M mass is suspended from a spring at a negligible mass. M mass is suspended from a spring of negligible mass, and the system oscillates with a frequency f1. The frequency of oscillation if a mass 9 m is suspended from the same spring is f2. Okay, so from the spring we have a mass m. Now in the second case we have the same spring but the mass attached is 9 times m. What will be the rate value of f1 is to f2, right? What will be the value of f1 is to s2? This is something you have to figure out, right? This is something you have to figure out. Try to answer it. Meanwhile, I will give you the options and all. All right. So try to solve it, and here I'll give you the options. Yeah. And this is the poll ready for you. So just try to answer it. What will be the ratio of the frequencies in this situation? So when a particle is performing SHM on a spring, so what is the frequency? 1 upon 2 pi under root m upon 1 upon 2 pi under root k by m, right? 1 upon 2 pi under root k by m, right? So in the first case it is this. In the second case, in place of mass it is 9 times m. K will remain same because the spring is same. So the ratio of frequency can be figured out without even picking the pen, right? So under root 1 upon under root 1 by 9, which is 1 upon 3. So 1 upon 1 upon 3, it is 3 is to 1. So f1 upon s2 will be 3 is to 1, right? So let's see. Yeah, so I was expecting everybody should give the correct answer, and is this time it was Sanya that gave the correct answer first, and then we have Shreyansh, Divya, Shravan, and Ananya, and then Kanva, and Surya. All right. So yeah, that was the correct answer. This is the ratio, right? Now here we have the combination of springs going into the play, right? Now we know that when the springs are added next to each other, their stiffness adds up, and when their springs are added one after each other, their stiffness add in a different way, which is pretty much similar to the resistance in parallel, right? So strings pretty much behave like capacitors, you can say in that way. So here the time period of simple harmonic motion m is given like that. What is the value of alpha in this situation? What is the value of alpha in this situation, right? Time period you have to figure out. To know the value of time period, here you have to just get the stiffness coefficient of this entire thing, right? If you can calculate the stiffness of the new spring, you can easily calculate that. And the options, let me give you. Right, try to solve it and get the value of answer. Right, these are the options you have, right? Look into this. So the springs are attached in this way. First of all, just try and get the overall stiffness of this thing. The time period is, again, you can easily calculate. In this one, just frequency is something you stiffness is something you have to talk about. Just talk about the stiffness of this part. It is going to be K and K. What is that? 2K. And again, 2K and K are added in series, right? And then the whole thing is added to that, right? So 2K and K are added in series. The net stiffness of this arrangement will be 2K into K upon 2K plus K, which is 3K. All right. So 2K upon 3K plus K, which is 5 by 3K, right? So the whole thing has a stiffness coefficient 5 by 3K, right? Angular frequency of this thing is root K by M, right? The root K by M, the whole thing has equivalent stiffness is 5 by 3K, and from there you can get the value of angular frequency, and any other value you can calculate from that. Time period is omega is 2 pi by t. From there you can calculate the time period. No worries about that, right? So what is the correct value, right? So yeah, some kids gave the correct answer, some gave the incorrect answer, and Shreyanshi was the first one, then Divya, then Ananya, Shoaib, and then Shravan and all, right? All right, so here you have it, equivalent value you can figure out from this part. Omega is root K by M, no worries about that, right? And T is equals to 2 pi by omega. From there you can get the value of time period. Here by comparing it, the time period was given pi root alpha m upon 5K, and here you have क्या हो गया भाई, just a second. All right, just wait for a second or so. I believe everything should be fine. So I believe the idea is very, very clear, right? And in this kind of problems as well, we can solve it, right, without any further delay. So let's start talking about it. Oh, okay. All the inputs are taken now. All right, so having done all that, now we can move ahead and talk about the new part, which is electrostats, right? So grade 11th portion, I believe, is revised very well, right? And now we can enter into the second part, which is the second part of the session where we are going to revise the grade 12th topics, right? So let's take a moment and start talking about grade 12th topics as well, right? Once we have revised it, we will have a good set of problems with us, right? And we can use that kind of problem set so that we can challenge us anytime we want, right? All right. So just a second. How many questions to go? So number of questions, whatever questions we have solved, you can say that almost half of that, right? So yeah, let's start right away. If you guys want a little break, I can give you 5 minutes of break, but I don't think so. I don't feel tired at all, right? And if we go a little fast, we can complete it in, let's say, 1 hour or so, because grade 12 topics are really simple. They don't need that much of discussion. They are going to be formula based, right? From the NEET perspective, what I've seen, the questions that are asked from the grade 12th topics, they are mostly formula based, right? Here I have picked some of the problems which were asked or the patterns of the problems which are asked, right? And we will try to look at that and we will try to solve it. Okay, so let's have a look at that. Break, dinner break. Okay, just wait for 1 hour, right? I'll try to complete the whole thing, right? Okay, don't talk about the breaks now, right? Just wait for an hour or so, Surya, right? And we'll try to complete it, and by the end of it we will also have a very good practice with us, right? So if we have electrostats with us, right, basic formulas of Coulomb's law and all are there. So just look at this question and try to solve it. So there are two charges Q1, Q2, they are separated with a distance d and they are placed in a medium of dielectric constant K. What will be the equivalent distance between the charges in the air for the same electrostatic force? Think about it. Very simple problem, right? What is happening here? There are two charges. Look at that. Let me Start the poll meanwhile. So there are two charges Q1, Q2. They are separated by the distance d, and they are placed in a medium of dielectric constant K. What will be the equivalent distance between the charges in air for the same electrostatic force? Right. Of course, when you remove the medium of dielectric constant K and the force wants to be same, the distance between them has to be changed as well. What should be the new distance? Please see the leaderboards. Okay. All right. Simple problems. All right. So let's see that who has given the correct answer, and then we will start looking at that. So here we have this one. Shravan has given the answer fastest, and then we have Shoaib. I guess it's Sanya, and then we have Ananya, then we have Shreya, then we have Surya, and Kanwar, then we have Divya. All right. So now when we think about it, here we just want same forces, right? And when we think about the same forces from the Coulomb's law, right, there are two charges Q1, Q2. The force is simply K times Q1, Q2 by R square, right? For the air, the K will be 1, right? If the forces has to be same, right, the forces has to be same. Force in air should be same in force in medium, right? Here, force is 1 upon 4 pi epsilon naught Q1, Q2 by R square, and here 1 upon 4 pi K times epsilon naught Q1, Q2 by R square, sorry, right? So you see that this part is same, right? Epsilon naught is same. This K will coming out like that, right? Q1 and Q2 are same. Let's say the distance between the particles in the medium is d, while in the air it is d air, right? So it is coming out to be d root K, okay? 1 upon 4 pi epsilon naught Q1, Q2 by R. All right. Look at this question, and similar kind of question is there. Force between 2 point charges Q1, Q2 placed in a vacuum R at a distance F. At a distance R is F. Force between them when they are placed in a medium having dielectric constant K is 5. At R by 5 apart will be. So clearly you have reduced the distance, right? You have changed the value of dielectric constant. Now the new value of K will come into the force will come into the picture, because it is 1 upon 4 pi epsilon naught K Q1, Q2 by R square. Now what is changed? The K is changed and the R is changed. The new value of force can be easily figured out. I don't need to tell you much about this kind of problem. Very simple, right? And these kind of problems are asked many times in the NEET exam, because this is the kind of pattern I've seen them repeating. All right. Just change R, just change some of the parameters and get the new value of forces. All right. Let's see who is giving the correct answer. Tanya is saying, watching this session feel like garden, sir. All right. Crazy. So I believe the idea is very, very clear. Let's have a look at that. So here we have it. Oh, I guess the leaderboard was not visible also. No problem. I can give you the poll once again. Right. Can you see the poll right now? Yeah, just try to put the answers again. I believe the poll did not recorded your answer, right? A question is simple, very, very simple, right? Yeah. Simple kind of problems are there. Force between the particles are there, right? So simply Q by R square, where K is 1 upon 4 pi epsilon naught. That K is dielectric constant, but here I am using different value. All right. Now let's see. Yeah, so we have a split. So Divya and Surya has given the correct answer. I believe some kids have done the mistake, right? No worries, right? So what is happening here? Clearly you see in air it is this 1 upon 4 pi epsilon naught Q1, Q2 by R square. In medium, it is 1 upon k times the same thing, right? So q1, q2 is same, r square is there. Radius distance is reduced by 5 times, no? So it is r by 5. So that becomes in the numerator, it is 25 times, right? So yeah, it is 5 times f. Some kids might have done it, like more kids have done this question wrong because of silly mistake maybe, right? They have not accounted the change in the value of r maybe, right? Which is why they got 1 upon 5 times, right? Okay. Now you have the questions on electric dipole. Look at this question. Again, very simple kind of questions are asked in the NEET exam from this topic. Two charges q and through q are separated by a distance r in the air. At distance x from the charges q, the resultant electric field is 0. What will be the value of x? What will be the value of x in this situation? Right. Again, you have your pole. Right. So if you remember the formulas directly, right, you can, go ahead with this one, right? If you want a formula session next week, you can definitely tell that in the comment section. In the next week, I will make notes for you where I will put all the formulas of the entire physics, at least for the grade 12th, right? And I will explain you all the formulas one by one. So in, let's say in 1 hour, you will have an audio video version of your formula, right? So that you can watch it again and again while you are sleeping, while you are going to washroom, right? Watch it again and again, and all the formulas will be copied to your brain, right? Okay. So yeah, let's see that how many of you have done it correctly, right? Okay, so let's see. Oh, everybody has done it correctly. Simple numerical. Shravan, Surya, Shoaib, which is Sanya, and Divya has done it correctly, right? So clearly, the same thing is there. The similar concept is there, right? So we have a dipole, and we are in the case of that, we have two charges q and 3q. They are separated by distance r at a distance x from q. The resultant electric field is 0. What will be the value of x? So let's say that a distance where the net force is 0 is this, which is at a distance x away from it. So we said that the net force is 0. That means there is no net electric field over here. So electric field at a distance x and electric field at distance r minus x should be cancelling out. They must be same, right? So kq by r square should be same for both of them. And by solving that, we should be getting the value of x, right? Look at this numerical and try to solve it. The electric field due to a short electric dipole at a large distance r from the center of the dipole on the equatorial plane varies with distance as. So which of them should be the correct option, right? Try to solve it, right? The electric field due to the short electric dipole at a large distance r from the center of the dipole at an equatorial plane varies the distance as, right? Of course, they are talking about the magnitude of that thing, right? Electric field is a vector quantity, and they are talking about the magnitude of that thing, right? So clearly, we know that the electric field due to the electric dipole on the equatorial plane is k into 2p by r cube. So definitely it is varying with the r cube. D should be the correct answer. Okay, again, I believe the poll has not recorded the answers. No problem, right? So D is the correct option, right? Those who are giving the D are correct. So let me tell you by telling the name here. So Surya has given the correct answer. Sanket has also given the correct answer. Very nice, right? Okay. So now let's look at the concept of this thing, electric flux. And here you have certain questions from this one. So from the Gauss's law, you can apply it and try to solve it. This kind of questions are asked multiple times in the NEET exam from the Gauss's law. Look at that. C1, C2 are two hollow concentric cubes. C1 is this one. C2 is this one. C1 and C2 are two cubes, this cube and the bigger cube. Inside the smaller cube, the charge enclosed is 2q, and then there is a charge 3q outside it. Okay, there is a smaller cube that is enclosing a charge 2q in it. Then there is a bigger cube that is enclosing 3q as well, right? The ratio of electric flux passing through C1 and C2 will be, what will be the ratio of electric flux passing through C1 and C2? From the Gauss's law, my dear kids, the value of electric flux that is there depends on only one thing, that is how much charge is enclosed by the geometry, right? So flux is dependent on charge enclosed upon epsilon naught. You call it that way, right? Gauss law briefly. Explaining the Gauss law is very simple, right? You can understand in this way. For the Gauss's law, you need a closed surface, right? Okay. So let us just take it this way. So here you have it. Imagine that it's a light bulb, right? Okay. Light bulb, and light rays are coming out in all direction from the light bulb. Here you take a closed surface, maybe a sphere or cube or anything, a closed surface, right? Maybe any shape. You can take this bottle, it's a closed surface. Think about it. Let's say 10 light rays are entering this side. So what will happen? On the other side of the closed surface, the 10 light rays will leave as well, right? So if the charge is outside, the electric field lines entering due to that charge and electric field lines leaving due to that charge are same, right? So what will be the net flux which is enclosed or associated with that closed surface due to this charge which is outside? Tell me in the chat box. What is the net flux associated with this enclosed surface which is due to the charge outside? Right? What is the net charge enclosed by this thing which is outside? So we can say that, yeah, it should be 0, right? But if there is a charge inside, so what will happen? The field lines are now associated with it. Effectively, 6 lines are going out of the surface, right? Clear? Let's say it's a positive charge, so 6 lines are going out of the surface, right? If there was also negative charge, let's say negative charges are like this, lines enter into that. So due to negative, let's say 3 lines are entering, and due to the positive, 6 are going out. So effectively 3 lines are going out. Okay, making sense? So I believe the net flux associated is due to the net charge enclosed. The smaller cube is only enclosing this smaller charge 2q. The bigger charge 3q is outside. So basically it is not contributing to any flux in this one, right? But for the bigger one, both of them are enclosed and both of them will contribute, right? Okay. So yeah, so the kids are giving the option. Let's see the result, right? Let's see the result. So here the smaller cube is going to give you C1 is going to give you 2 and that is going to be 5. So C should be the correct option. Right, nice, very nice. Let's see. Oh, many kids have done it wrong. They have done 5 by 2. C1 was the smaller cube, C2 was the bigger cube, I told you. Right. C1 was the smaller cube, C2 was the bigger cube. C1 is only enclosing 2q and C2 is all enclosing both of them. Many kids might have done this thing. They have taken C1 as an outer cube, C2 as an inner cube. That's why they have chosen it. I believe that was the major problem, right? So now let us move on and talk about another one, right? Look at this one and try to solve it. Let sigma be the uniform surface charge density of 2 infinite thin plates. Then the electric field in 3 different regions. First, second, third. In these 3 regions, what will be the electric field? This is something you have to answer, right? Wherever you have to find out the electric field, at that place you imagine a unit positive test charge, right? You imagine a unit test charge over here. The positive plates and the positive plates will repel it. So the net field is in the opposite direction, negative x direction, right? Here, the positive charge, if you imagine, this and this will repel it in this direction. So because both of them, the net field is adding up in the positive x direction. So the net field is in the positive direction. If the positive charge is imagined over here, this plate is repelling this way, this plate is repelling this way. So here they are cancelling out and there is no net field in the region in between, right? So here what will happen, sigma upon 2 epsilon naught is the field in front of a sheet of charge. So here they are adding up but in the negative x direction. So minus sigma upon 2 epsilon naught 0 and plus sigma upon 2 epsilon naught. So just add that up, sigma upon 2 epsilon naught plus sigma upon 2 epsilon naught, sigma upon 2 epsilon naught plus 2 sigma upon 2 epsilon naught. Keep the direction in mind and plus and minus will come from that part, right? So I gave you all the hints. Using those hints you can solve it. 30 seconds, right? Try to solve it. Very nice, Shreyansh. Very nice. Great. Let us move on and talk about the next question. It is sigma upon 2 epsilon naught plus sigma upon 2 epsilon naught. Just add it up in the negative x directions, and minus sigma upon epsilon naught 0 and plus sigma upon epsilon naught. So yeah, just add it up. Oh, pole is there. So pole is there, right? Let us see what is the result, right? So minus sigma upon epsilon naught 0 and plus sigma upon epsilon naught. So option C should be the correct option. Okay. Let's see how many kids were correct. So nobody clicked on C. Why? But anyways, this is the correct answer. Why minus sign? Because at this place we are going into the negative direction of x-axis. Here we have 0 and here we are going in the positive direction of x-axis. So this is the question you can learn from, right? So yeah, this is it. So in the first region, both of them in the opposite direction of x-axis. In the middle region, they are cancelling out. In the third region, they are in the positive direction of x-axis. Right. So let's talk about the potential now. Look at this thing. The electrostatic potential due to an electric dipole at a distance r varies with this 1 upon r cube. It is 1 upon r cube, 1 upon r, 1 upon r square, or only r. So this is something you can answer. Simple numerical, direct formula based question. Again, as I said, from the grade 12th, things are going to be much simpler, right? So what is the potential for this for a single point charge? It is Kp cos theta over r square, right? Kp cos theta over r square. Based on that, you can easily solve it, right? Okay, so time is up now. Let's see that how many kids have done the correct option, right? So let's see. Kp cos theta over r square is a thing, right? So Kp cos theta upon r square. So option C is correct. No brainer. Only 50% have done it correctly. Some have done is r cube. But yeah, they are asking about electric potential, right? So the formula was already directly very clear. Surya has done it correctly. Okay, let's move on and talk about the next one. It is this Kp cos theta over r square. So V is inversely related to the r square, no? So this is capacitance. Okay, look at this system. Two identical capacitors have the same capacitance C. One of them is charged to the potential V. The other is charged to the potential 2V. The negative ends of both are connected together. When the positive ends are also joined together, the decrease in the energy of the combined system is. It's a good question. This question is going to tell you a lot of interesting concepts. I guess 2 or 3 concepts can be learned from this one, right? So you just try to solve it by your own self. Meanwhile, I will explain the logics to the kids who cannot solve it, right? So you see that when two things are connected with certain capacitance, let's say this is the first body with certain capacitance C1, the other body with certain capacitance C2. They don't have the same capacitance. Now, if they are connected, capacitance is there, so they have stored some charge, right? But they don't have same capacitance, so they do not have stored same value of charges, right? Okay. So what is happening? If they are connected with a wire or they are touched with each other, so the charges will transfer from one body to the other. What is the nature of transfer, or what is the direction of transfer? Charges will transfer from higher potential to lower potential. This is how the charges move, right? Charges will transfer from higher potential to lower potential, and they will continue to transfer until one is higher and one is lower, right? So once the situation is arrived when the potential of both of them becomes same, then the transfer of charge will become transfer of charge will stop, right? So this is the main idea behind it, right? Until when the charge transfer takes place, we can say if two bodies are connected, the charges will keep on transferring till they have the same value of potential, right? You see that two identical capacitors have the same capacitance C, same capacitance. One of them is charged to potential V and other one is charged to 2V, right? So the value of charge stored is Q is equals to CV, CV and C into 2V. The total charge stored is 3 times CV, right? The negative ends of both the capacitors are connected together. So let's say this is one capacitor, this is another capacitor, negative, negative, positive, positive. So negative ends are connected together and positive ends are also connected together. So they are connected in a parallel combination, right? What is the net capacitance of this arrangement? Right, capacitance are arranged in a parallel combination. Think about it, the net capacitance you can figure out right now, and here the net energy of the system was half CV square and half C2V square. The net energy was this much, and now net capacitance you can figure out, potential of both of them will be same, right? And now think about it, what will be the new value of thing, right? Let's see, first of all let us see how many kids have done it correctly, and then we will look at how to look at that one. Right, so as I can see, some kids have done it correctly, which is Shreya. Shreya has done it first and correctly as well. So let's see that how to solve it. So it is very opposite as what I have expected, right? I had expected that many kids will do the grade 12th problem with more accuracy than the grade 11th problem. Grade 11th problems were, however, much more difficult than the level of problems we are solving for grade 12th. But in the grade 12th problem, kids are doing mistake, which is weird. Right. So here you see that energy of the capacitor is half CV square. Before you have connected them, you see that the first capacitor has energy half CV square, the second one has potential 2V. So it will have half C into 2V square. So when you add them up, the total energy initially was this much, right? But once you arrange them in such a way that their positive ends are together, negative ends are together. So what will happen? They will share the charges until they have acquired the same value of potential. So basically, how will you know the final potential? If you have connected two capacitors, positive, positive, negative, negative, so they will share the potential until they acquire the same, they will share the charges until they acquire the same potential. But the thing is, the total charge will remain conserved, right? The total charge before transfer is same as the total charge after transfer, right? So let's say for the combined arrangement, the net potential is VF, right? So capacitances are C and C, in parallel they add up, right? So before you joined it, the charge stored in this one was CV and charge stored in this one was C into 2V, right? After joining, the common potential of this arrangement becomes VF, right? And the net capacitance is 2C into VF, right? So what will be the value of VF? It is 3V by 2, that is going to be VF. This is the final voltage of the final potential of the capacitor, or final potential difference across these capacitors will be 3 by 2 VF. So once you know that, you can get the new value of energy, half CV square, half CV squares. Instead of C, you have 2C, and V, you have 3 by 2 V square. You can easily put the value and get the final answer, right? Okay, difference of energy you have to find out. So initial minus final energy and initial energy, you can put it and get the value. This is the drop of energy you got. Okay, let's move on and talk about the next one, current electricity. Again, simple kind of problems are asked in the current electricity chapter as well. There is no need to solve very complicated problems from the chapter of current electricity. This is what I've observed. Even if you're solving the simple level of problems with a lot of dedication, right, you will find that you can solve the NEET level problems of this chapter very accurately. Especially the kids who are confused and they are very much agitated with the syllabus of grade 12th. They are talking about the current electricity. They are investing way too much time on this chapter. I'll suggest you to focus on the simpler portions of this chapter. right? Especially the theoretical portion that you skip, that is drift velocity and all. Those portions, if you complete well, that is going to serve you well enough, right? And do not spend too much time on solving complex circuits if you have not solved it already, right? I have uploaded a single one shot of current electricity. There I have given you some tricks to solve the questions of current electricity. If you just go through that one only, that is going to be more than sufficient for now, right? If you are weak in that chapter, you can do that, right? Otherwise, we can start right away with this one. Okay, so let's have a look at that. So here you have a circuit, a potential divider circuit is shown in the figure. The voltage output is, so what is the voltage output across this section, right? Now, the kind of concept I found repeatedly asked in the NEET exam in the circuits, they were willing to tell you that how much current is being drawn by the circuit depends on the total load on the voltage source, right? So they are asking about the voltage difference about this portion or this portion. That is not something we need to worry about. But if I need to think about how much current will be drawn out of this power source, that is decided by the overall load of this circuit, right? So you think about the overall load, right? It is 3.3 kilo ohm, sorry, 100, 100, 100 and rest of them are 100 ohms, right? So you have to think about in that way, right? If you do that, you can calculate the voltage output across the remaining circuit as well, right? So try to do that and try to solve it. So let me just share the poll with you for now. You can now put the answer in the chat box and I can answer it. Questions are easier, right? Very good. I like this confidence. It is saying if this question is repeated, I have the ability, I can solve it. 3.3 kilo ohm, 100, 100, 100. The voltage output across this portion you have to figure out, right? The common concept which is being asked repeatedly in the NEET exam is they were interested so that you can focus and find the value of current you can draw out of the power source. And the concept is same. The current you can draw out of the power source depends on the total load of the battery, right? Use this hint and try to solve it. Nice. All right, so poll is completed now. Let's see that how many of you have done it correctly, right? And now we can talk about this part. Oh, everybody has done it correctly. Nice. Shreyansh has done it correctly first, then Hershey, then Surya, then Ananya, then Shubha, then Sanya. Right, so let's look at that. So here we have it. The output voltage V0 we have to figure out. First of all, if you think about the value of current, the current we can get out of this power source is V is equals to IR. So I is equals to voltage upon net resistance, the total applied resistance. So 4 volt is the voltage applied, right? And net resistance is 3.3, 100, 100, 100, 100, 100, 100, 100. So 1, 2, 3, 4, 5, 6, 7. And that is added to 700 ohm is added to 3.3 kilo ohm. That is 3300 ohms. So total is 4000 ohms. So it is 1 by 1000 ampere. That is how much current you are drawing out from the circuit. And now this, all of them are connected in series. So all of them are sharing the same current itself, right? Now you want to know the voltage difference across this portion. So V is equals to I into R. For this portion 1, 2, 3, 4, 5. 5 resistances are there. So 500 ohm. And current is 1 upon 1000. So 500 into 1 upon 1000 is how much? 500 into 1 upon 1000 is 1 upon 2 only, which is 0.5, which is option C. I believe the idea is very, very clear, right? Okay. Now let us move on and talk about the next idea. Look at this question. In the given circuit, the current in the resistance R3 is, so this is R1, this is R2, this is R3, this is R4. R1, R2, R3, R4. We have to find the current in this portion, right? Again, voltage divider circuit, current divider circuit. These are the kind of problems you can expect in the NEET exams, right? However, sometimes they are also asking the questions based on connecting wire problem. Those kind of problems I have explained in detail in one short video. If you are weak in that chapter, there are 5-6 types of problems I have explained, right? And that will help you a lot, right? So if you get time, or if you want to repeat that topic, if you want to revise that topic, there are gaps in your understanding. On the same channel, there is one shot, you can watch it, right? So just go through this one. Okay. So, oh, I forgot to give you the poll, right? So let me give you a 30-second poll for this one, simple numerical, right? Right, so just go ahead and try to solve this one, right? And that should give you a very good idea about it. All right. Again, the concept is same. The current drawn out of this power source depends on the total load of the circuit, right? The total load you have to calculate and use this voltage. That will help you to get the value of current you are drawing out. Once you know the current you are drawing out, you can calculate how much current is going in this arm and how much current is going into this arm by current divider rule, right? Very nice. Let's look at how many kids out of you are giving the correct option, right? How many kids are giving the correct option? Let's have a look at that in this way. So some kids are giving the correct option, some kids are not, right? So Truth, Craft and Sanya, these were the prime kids who gave the correct answer. Now, no worries about that, right? If you did not do it correctly, first of all, get the value of current. Current is simply the same concept. Total load of the circuit, right, decides the value of current that will be drawn out of this thing. So current is 10 volt upon total resistance, right? Okay, and then step 2, once you know the value of current, you can apply the voltage current dividing rule to find the value of current in this arm. Very easily you can do that. Let me show you how. So this is the first step. Total load is going to be added up. This is in parallel. This is in these things are in series with that. So the net resistance came out to be 5 ohm, and the current is, the total resistance is 5 ohm. So current that is drawn out is 10 upon 5, which is 2. So 2 ampere is drawn out. 2 ampere is divided into these two parts. So how will you divide the current across two arms? One arm has a resistance R1, the other arm has a resistance R2. So we have the net current into R2 upon R1 plus R2. This is 4 upon 4 plus 4, which is 1 ampere, right? So 1 ampere current will go in this one, this arm, right? So clearly the idea is very, very clear. All right. By what percentage will the illumination of lamp decrease if the current drops by 20%? This is something you have to talk about. Now, the illumination of lamp, they are not talking about LED lamps. They are talking about those incandescent lamps. The fundamental nature of incandescent lamp is, the more you heat it up, the current flows through the lamp, it heats up the filament, and upon heating up the filament, it emits light, right? And if you increase the current, it heats up more, it emits the light more. Right now, you reduce the current by 20%, it will heat up less and the light will also be lesser, right? Based on that logic, you can solve this question. Try to solve it. Based on this logic, you can solve this question. Very good, Sanya. Right. If it's your first attempt, for the first attempt, the level of questions you have done is very nice and your preparation is going decent enough, right? So just stay on the same pace and best result is waiting for you for sure. All right. So here it is, right? So let's see that. How many kids are giving the correct answer? Okay. I guess the poll hasn't recorded correctly, but no worries. So let's look at that. So of course, the heat or the power required is I square R, right? Heat is I square R into T for the time the time t is total amount of heat which is created, right? So I square R is the illumination, the power that is invested in illumination. Current is reduced by 20%, so the new current is 0.8 times the original current. So now it is going to be 0.8 times I, original current. So difference of this thing you can calculate, right? And percentage you can calculate, delta P upon P into 100, right? So yeah, you can do that. So P and P, initially it was this I square R. Finally, it is reduced by 20%. So the new value is 0.8 times I into R square. And then you can get the value of percentage change minus 36%, right? All right. The next concept is the concept of drift velocity from this chapter, right? So look at this question and try to solve it. Look at this one and try to solve it, right? The drift velocity of electron for a conductor connected in electrical circuit is Vd. The conductor in a row, conductor is now replaced by another conductor with same material and same length but double the area of cross section. The applied voltage remains same. The new drift velocity of the electron will be. What will be the new drift velocity of the electron? Try and answer it. Right? Easy question. You can answer it. Shreyanshi. No, actually we have to do some more, right? Okay. थोड़ा और पढ़ते हैं, थोड़ा और सॉल्व करते हैं, right? Sir, drink some water. सूर्या को थोड़ी चिंता तो है कम से कम. All right. So let's have a look at that and let's see how many kids are giving the correct answer. Right. So drift velocity we need to talk about in this particular situation. All right. So what is happening in this one? The drift velocity of the electron depends on a certain parameter, right? So let's look at that. Let me explain you this concept, right? Drift velocity is E tau upon m. In terms of relaxation time, the drift velocity when the electric field is E tau upon m, where E is the charge of this electron and m is the mass of this electron. This minus sign is multiplied with the charge of the electron, becomes the drift velocity positive, right? Now what is happening? If V voltage is applied, what is happening in this situation? The conductor is now replaced by another conductor with the same material and same length with double the cross sectional area. The applied voltage remains the same. Only the area is changed. You see that doesn't really affect the drift velocity in this situation, right? So anything that does not changes the relaxation time does not affect the drift velocity, right? Okay, so relaxation time is affected by more collisions between the atoms. That is affected definitely by the temperature of this thing. Okay, now look at this arrangement. It's a Wheatstone kind of arrangement in this situation, right? Look at this. To measure the temperature coefficient of resistivity alpha of a semiconductor, right? Alpha of semiconductor, you are connecting it in this part. An electrical arrangement is shown in the figure. The arm BC is made up of semiconductor. The experiment is being conducted at 25 degrees centigrades and resistance of the semiconductor arm is 3 milliohm. So the resistance of this arm right now is 3 milliohms. At what temperature? 25. Arm BC is cooled at a constant rate of 2 degrees Celsius. Arm BC is cooled at a rate of 2 degrees centigrade per second. This arm is cooled at a rate of 2 degrees centigrade per second. If the galvanometer G shows no deflection after 10 seconds, then what is the value of alpha? This galvanometer shows no deflection after 10 seconds, then what is the value of alpha? Galvanometer shows no deflection means Wheatstone bridge is balanced, right? After 10 seconds it is balanced, right? So what will be the new resistance of this particular arm? Okay, that is something you have to figure out. Okay, think about it. If in the next 10 seconds the idea is same, right? They are telling you no deflection but after 10 seconds, and you see that it is cooling at a rate of 2 degrees centigrade per second, right? So what is the value of alpha? Okay, so try and solve it. Here you have your whole, right? If you can solve it, it is good. If you cannot solve it, I will tell you how to solve it. All right. The semiconductors behave in the opposite way as compared to the normal conductors, as you know, right? Normal conductors increase the resistance with increase in temperature, and semiconductors reduce the resistance by increasing in temperature, right? So you are doing what? You are cooling the whole thing at a rate of 2 degrees centigrades. So when you cool it down, the resistance of this thing increases opposite, right? So resistance is increasing, and there is a point when this is balanced, which is why the galvanometer is balanced. What is the value of alpha? So under that situation, you can get the value of resistance, and R is equals to R alpha delta T. Delta R is equals to R alpha delta T. From that part, you can get the value of alpha, right? So let's see that if you guys could do it or not. Yeah, some kids tried and did it. Shreyanshi and Kanva were able to do it. So let's see how to do it, this kind of problems as well. So nothing very serious about this kind of problem, right? So again, as you know, at after 10 seconds, this was balanced. So this and this ratio is same as this and this. This will give you the value of resistance after 10 seconds, right? So here you have it. For no deflection, the ratios must be matched. So after 10 seconds, this will be the resistance of the semiconductor branch, right? Temperature fall in 10 seconds. Every second temperature is falling by 2 degree. So how many degrees the temperature will fall? 20 degree. Initially the temperature was 25. It is falling by 20 degrees. So the new temperature is 5 degree only, right? So delta R is equals to R alpha delta T. The change in the resistance is how much? Change in the resistance is this much. Initially how much resistance was there? This arm BC had a resistance of 3 milliohm, right? After 10 seconds, when the whole thing was balanced, the new resistance is 2.4, right? Semiconductor arm had original resistance 3 milliohm. After 10 seconds, the Wheatstone bridge got balanced, and the new resistance of semiconductor arm is 4.6 milliohm, right? So what is the change in the resistance of that arm? It is 0.6 milliohm, right? Which is written over here, right? And R delta T. So value of R, original value, delta T, in 10 seconds 20 degree drop will happen. So delta T is 20. Put the values, you have the answer alpha, right? All right. Now the meter bridge is another application of Wheatstone bridge, where the ratios of these resistances match up with the ratio of the length, balance lengths, right? So this is what you know already, right? So look at this condition. The potential difference between B and D is 0. That means this arrangement is balanced Wheatstone bridge, right? What will be the value of X? This X we have to calculate. So this is what we can give you as a homework. With the logic is same. The ratio of this net resistance and this net resistance will come in the exact same ratio of these two. And by doing the same ratio equality, you can get the values of X, right? Now, we can move on and talk about the next chapter, which is this magnetic effect of electric current and magnetism, right? So magnetic effects of electric current and magnetism, right? Let us solve 5 more questions, right? 5 more questions only, okay? So don't need to worry about any of these things. 5 more questions will be solving. Magnetic effect of electric current and magnetism is there. So Biot-Savart law is there and all. So a regular polygon of 6 sides is formed by bending a wire of length 4 meters. If an electric current of 4 pi root 3 is flowing through that sides of polygon, the magnetic field at the center of the polygon would be x into 10 to the power minus 7. What will be the value of x? Simple, right? You are making a polygon out of a current carrying conductor, and you know that a current carrying conductor has a magnetic field right next to it, right? Okay, so in that situation, what will be the magnetic field right now? Okay, right? So try and solve it. Here, let me give you the value x into 10 to the power 7. Options are this. Options are this. So it is 72 into 10 to the power minus 7, 16 into 10 to the power minus 7, 52 into 10 to the power minus 7, or 32 into 10 to the power minus 7, right? Try and answer it in the chat box. Try and answer it in the chat box. बहुत बढ़िया. Okay. Think about it. Very simple geometry you have. You have a long wire and you are making it into a polygon of 6 sides. So once you have a finite wire and you want to know the value of magnetic field at that place due to a finite wire, this wire is carrying a current I. So mu naught I upon 4 pi, right? 4 pi r sin theta 1 plus sin theta 2. This is the value, right? For the finite wire. Okay. Sin theta 1, this sin this one and this sin theta 2, right? For the case of finite wire, this is how you calculate it. But you don't have a single finite wire. You are converting into the polygon, right? So this is converted into a polygon of 6 sides. So this is side 1, this is side 2, this is side 3. Now you have 6 sides. Now what will be the magnetic field at the center? So clearly one arm, all the arms are same size. So if you know the magnetic field because of one arm, magnetic field due to each arm will be in the same direction, right? You see that current in this way, magnetic field in this way, right? So all of the arms are adding up the magnetic field at the center, right? And if I know the magnetic field because of any of one arm, I multiply that magnetic field by 6, I get the total magnetic field. So I join this one, I join this one. This angle is 30, this angle is 30 because there are 6 sides. 360 by 60 is 60. So this arm is subtending an angle of 60. So each side is angle subtending is 30, right? So it is carrying a current I. So what will be the magnetic field? Mu naught I upon 4 pi r sin phi 1 plus sin phi 2. That is the value. Multiply that by 6. This will give the total value, right? All right. So kids are giving the wrong answer for this one, but no worries. So let us understand that how to solve it. So for a polygon, there is no direct formula to find the value of magnetic field, but there are 6 straight sides, and for one straight side you can find the value. So for the 6 straight side you can also find the value. For this arm, it will be mu naught upon 4 pi I by r sin theta 1 plus sin theta 2, sin phi 1 plus sin phi 2. Just put the values, and one arm is giving this much magnetic field. Current is this way, right? Magnetic field is inside at the center. Here current is this way, magnetic field is inside the center. Here current is this way, magnetic field is inside the center. Here current is this way, magnetic field is inside the center. Similarly from this arm and similarly from this arm as well. I believe the idea is very, very clear, right? Look at this question. The ratio of magnetic field at the center of the current carrying coil of radius r to the magnetic field at a distance r from the center of the coil on its axis root x is to 1. What is the value of x? Look at this question and try to solve it. Okay. Ratio of magnetic field at the center of current carrying coil of radius r and magnetic field at distance r from the current carrying coil. ये है center and a distance r from the center. So this is the point P and this is the point Q. Okay. So this is root x is to 1. You have to find the value, right? Very simple problem. You just need to know a formula, right? So this thing I can give you as a homework. Just remember 2 formulas: magnetic field at the center of a current carrying coil and magnetic field at an axis of a current carrying coil, and take that as a ratio. I have written it and you just try and solve it, right? This is very simple numerical, right? Let's try to solve this one, right? Look at this question and try to solve it. A single turn current carrying loop is in the shape of right triangle with a side 5, 12, 13 carrying a current of 2 ampere. The loop is in a uniform magnetic field of 0.75 Tesla, whose direction is parallel to the current in the 13 centimeter side of the loop. The magnitude of magnetic field force on 5 centimeter side will be x upon 130. What is the value of x, right? Good question, but not very difficult question. Question is saying that a single turn of current carrying loop is in the shape of right triangle with side of 5, 12, 13. Okay. All right. It's a right angle triangle. It is carrying a current of 2 ampere. Right. Okay. The loop is in a uniform magnetic field of magnitude that many Tesla. So it's a magnitude whose direction is parallel to the current. Whose direction is parallel to the current in 13 centimeter side. 13 centimeter size is carrying current this way. The magnetic field is also this way. All right. This is the magnetic field. And how much is that magnetic field? 0.75 Tesla. All right. The magnitude of magnetic force on 5 centimeter side. So this field is going to apply some force on this side. What will be the value of the force applied on the 5 centimeter side? This is the what you have to figure out. Force on 5 centimeter arm. This is what you have to figure out. Right. Try and solve it. Try and solve this particular problem as well. And here are your options. Right. Now you know that if a current carrying arm is placed in a magnetic field and it is cutting the magnetic field line, it will experience a force, right? If you know the basic formula, you should be able to solve it. Oh, I didn't give you the options. So the options are 10, 15, 9, 17. All right. So the value of x you have to figure out. And now you can answer it in the poll. Right. I gave you everything in this particular question. Once you visualize the question, then solving it becomes very easy. Right. The force is going to be simply ILB sine theta, right? The force is simply going to be ILB sine theta. Once you know that, you can simply calculate anything, right? All right. All right. So let's see how many kids are giving the correct answer. So here some kids are giving correct and some kids are giving incorrect answer. But Pratiksha and Kanva have given the correct answer as well. So let's see that how to go ahead with this one. So clearly right now the diagram I have already given. This side is parallel to the magnetic field, will not experience the magnetic force, but these two sides will experience the magnetic force. How much force will it experience? Depends on the angle between this and this, right? Now, you know that in this situation, right, the force on 5 centimeter side is going to be ILB sine theta, no problem with that. They have made this diagram, no problem. ILB sine theta. So what will the value of sine theta in this situation, right? What will the value of sine theta in this situation? In this triangle, get the value of sine theta, perpendicular upon hypotenuse, 12 upon 13. So just put the values and you will have the value of x is 9, right? No worries about that. Okay. So now I have already told you that every current carrying loop behaves as a magnetic dipole, right? And if you place it in an external magnetic field, experience a torque. Very important kind of topic for the NEET, right? They ask you multiple times what will be the force acting or what will be the torque acting on this current carrying thing if you place it in a magnetic field of this much intensity, right? They ask it multiple times, right? So try and solve similar kind of question in this domain as well. Sorted hai. ठीक है. All right, look into this particular question. A uniform magnetic field of 2 × 10⁻³ Tesla acts along the positive y direction. A rectangular loop of side 20 and 10, rectangular loop of side 20 and 10 with a current of 5 ampere is in YZ plane. Okay. The uniform magnetic field is in the positive y directions. You see, let's say this is the y axis, this is the z axis, right? And this is the x axis. Okay. The uniform magnetic field is along the y axis. Okay. All right. A rectangular loop of side 20 cross 10 with the current 5 is in the YZ plane. It is not in the X plane, it is in the YZ plane. Okay. So let's put the plane in the YZ plane like this. So the magnetic field is moving parallel to the thing, right? The current is in the anti-clockwise sense with respect to x-axis. Okay. The current is in anti-clockwise sense with respect to x-axis like this. All right. What will be the magnitude of what will be the magnitude and direction of torque is? What will be the magnitude and direction of torque? Think about it. Right. So these two arms are parallel to magnetic field. They will not experience any kind of forces. But this arm and this arm will experience a force. They are carrying the current in opposite direction. This arm and this arm. So they will experience the forces in the opposite direction, and that will form a torque. What is the value of the torque? Right. This is something you have to answer. Right. Use it, pole, use that pole and try to solve it. Okay. Slightly good question. You should be able to solve it. Think about it. Torque acting on a dipole, right? Let's say a loop, right? Or any dipole. If once you know the magnetic moment of that particular thing, you can calculate the torque of that particular thing as well. So if a loop is there, right, carrying the current I, area is A, what will be the magnetic moment of that loop? I into A, right? Once you know the magnetic moment and you place it in a magnetic field, M into B will be the value of torque acting on it, right? So let's see first of all how many kids are giving the correct answer, right? And that should give us an idea about it. Okay, so almost everybody gave the wrong answer. No worries about that, right? Okay, so here we have it. So magnetic moment of this current carrying loop is going to be I cross A. Just put the values. This is the direction of magnetic moment, and the direction of magnetic moment is towards the direction of area vector, which is I cap. Okay. Torque is M cross B, right? So M cross B, just magnetic field is given in the y axis, so it is J, right? The direction of this vector is perpendicular to both of them, right? So perpendicular to I and J is going to be perpendicular to minus I and J is going to be minus K, right? So clearly the direction of torque is 2 into the power 4 and towards the minus K axis, which is option A, right? Now let's move on and talk about this part, right? For the moving coil galvanometer, I have explained in detail with a diagram in the one shot video, right? I have used the diagram of that real life moving coil galvanometer, and I have used these formulas as well in the explanation part, right? So this is for you, for your reference, right? If you do not remember the formulas, you just go through it once so that you can recall the formulas. And now we can go ahead and talk about this particular part, moving coil galvanometer as an ammeter, right? So here we have the ammeter and we can calculate things out of it. Right, here we have the voltmeter, we can calculate things out of it, right? Sometimes they ask you in the NEET exam, we want to use it as a ammeter or as a galvanometer for this range. What should be the resistance that should be shunted with or should be added in series? We can use these formulas very easily and calculate it, right? So yeah, look at this question. This is the only question we are going to solve from this topic, and then we will move ahead, right? Read the question and try to solve it. We have a moving coil galvanometer. It has 100 turns. How many turns it has? We have a moving coil galvanometer. It has 100 turns, and each turn has an area of 2 centimeter square. Each turn has a radius of 2 centimeter square. The magnetic field produced by the magnet is 0.01 Tesla, and the deflection in the coil is 0.05 radian when a current of 10 milliampere is passed through it. So some magnetic field is there and some deflection you get when the current of 10 milliampere passes through it. The torsional constant of the suspension wire is this. What is the value of x? What will be the value of x in this situation? So the options are given. It is 4873. Right. Think about it and try to solve it. So you know that the torque acting on the coil of galvanometer is NIAB sine theta, right? Or sine phi, you can say. The phi is a deflection thing, right? How much deflection you are getting, okay? And the torsional coefficient for the suspension wire, if it is C, then C into theta gets balanced by the torque, right? The torsional constant, as I said, right? The torsion in the spring or the suspension wire balances the torsion produced in the coil, right? So NIAB sine theta gets balanced by K or whatever that suspension constant is, K theta, right? So that is balancing out things, okay? So let's see that. Yeah, here we have pretty much equal distribution. No worries about that. So here you see that torque is NIAB sine theta, right? And the torque is being balanced by the suspension wire. The torsion in the suspension wire balances it. So if you are twisting it for an angle theta, the torsion is C into theta, right? From here, the torsional coefficient C is NIAB upon theta. You just balance it out and get the value of X, right? So we will not be solving similar questions again, right? Now look at this, right? 2-3 questions will be solving more, right? Then I'll let you go. Look at this question and try to solve it. There are two particles X and Y. They have equal charges, are being accelerated to the set through the potential difference, right? Through some potential difference. Thereafter, they enter normally in a region of uniform magnetic field and describe a circular path of radius R1 R2. The mass ratio of X and Y is. See that there are two particles X and Y. They have equal charges. They are being accelerated through the potential difference, right? Through some potential difference. Thereafter, they enter normally in a region. Okay, so R1, R2, we have to find the ratio of mass ratio of X and Y. Okay, we have to find the ratio of mass ratio of X and Y. So there are two particles accelerated and entering normally to the magnetic field. Of course, when the charged particle enter perpendicular to the magnetic field, it moves in a circular path. Radius of the path is mv upon qb. Try and think about what will be the ratio of the path they are going to inscribe, right? Their masses, their charges are same, right? And the masses, mass ratio we have to find out, right? They are moving in the radii of R1, R2. We have to find the ratio of masses. All right. All right. Great. All right. So kids are giving the answer, and D. Okay. Yeah. Best answer was given by Khanwan and Surya, and then we have Sanya. Sanya has and Khanwan. These kids are giving very accurate answers from the beginning of the session till now. Now you see that the mass ratio of X and Y we have to figure out. No worries about that. You know that the formula I have already told you. Radius of the path when they are going to enter into perpendicular to the field is mv upon qb, right? So mv is p upon qb, right? It is this. So radius is proportional to under root of mass. Mass is proportional to square of this thing. So m upon m1 is r1 upon r2 whole square. No worries about that part, right? Okay. All right. So let's solve two more questions, two more good questions in this list. So we have electromagnetic induction and alternating current one together, right? So we are going to solve this one, and that is it, right? Just a second. All right. 2-3 questions we are going to solve about this one. So this is Lenz's law and all. So look at this question and try to solve it. A rectangular loop of length 2.5, width 2 is placed at an angle 60 degree to the magnetic field of 4 Tesla. The loop is removed from the field in 10 seconds. The average EMF induced in the loop during the time is. What is the average EMF induced in the loop in this time? Right. What is the average EMF induced in the loop in this particular time? Think about it. So here you have it. Very simple kind of question. Flux through any coil when it is placed in a magnetic field B is B dot A or B A cos theta, right? When this coil is removed from the magnetic field, you see that the loop is removed from the magnetic field in 10 seconds, right? So time is 10 seconds. Final flux will be 0, right? So B A cos theta minus 0, change in flux you will get, and divided by time, you will get the value of EMF, right? So EMF is nothing but rate of change of flux, that's it. So here I can see most kids are not giving the correct answer for this one. Like this is surprising that these simple questions are where kids are doing mistakes, and in much more difficult questions kids have done no mistakes, right? So here you see you have a loop of certain area, right? So this side is 2.5 meter and this side is 2 meter, right? This is placed at an angle 60 degree to the magnetic field of 4 Tesla, right? It is placed at an angle of 60 degree to the magnetic field of 4 Tesla. Magnetic field is 4 Tesla and this loop is placed at an angle of 60 degree with it. So yeah, so normal to the loop is making an angle of 60 degree to it, and it is removed from the field in 10 seconds. The average EMF induced in the loop in this time is going to be. So you see that phi is BA cos theta. This is the value of magnetic flux through it, right? So clearly, if this is the thing and this is the magnetic field like this, right? So right now what is happening? The initial flux is BA cos 60, right? So initial flux is simply multiplied that and you got the initial value of flux. Area is simply length into width, right? You can get it. Initial flux you can get, right? Okay. So once you are removing it from the field and it is outside, the final flux is, the final magnetic field passing through this one is 0, right? Initially it is placed in the magnetic field at some angle, right? So the flux associated is BA cos theta, which is this. Once you take it out of the magnetic field, the flux associated is 0, right? How much is the flux? Finally, it is 0. So change of flux is 0 minus 10. Initially, it was 10 Weber, then it is 0. So 0 minus 10. It is that this is change in flux, delta phi. And that change of flux is happening in 10 seconds. Why? Because it takes, you take 10 seconds to take it out of the magnetic field. So delta phi by delta t, it is 10 upon 10, it is 1. So EMF will be 1 volt. Answer is very clear, right? Look at one more question and try to solve it as well. Look at this question. The magnetic flux linked with the closed circuit of resistance 8 ohm varies with time. Phi is this. The induced current in the circuit is very simple numerical, right? Again, it is based on a very simple concept, right? And these kind of questions are asked many times in the NEET exam. Generally, they ask you these kind of simple questions as well, right? So the options I can give you: 5 ampere, 3 ampere, 2 ampere, 9 ampere. Try and answer it in the chat box, right? Hi Shreyanshi. All right, quickly solve it. Crazy. All right, so everybody is giving the answer now. Right. All right. So let's see if anyone is giving the correct answer or not. So let's see that who is giving the correct answer first of all. So yeah. So everybody gave the correct answer, and the fastest answer was given by Shreyanshi, and then we have Pratiksha, Surya, Sanya, and then we have Ananya. All right. So yeah. So this is it. So let's move ahead and talk about this idea. Right. So the EMF produced is simply rate of change of flux through it, and they are already giving you the flux is 5t square minus 36 plus 1 differentiated 10t minus 36 plus 0. Right. At t is equals to 2, just put the value 10 into t, which is 10 into 20 minus 36. So 20 minus 36 is minus 16. Right. And that will be the value of EMF. 16 is the EMF, 8 is the current, 8 is the resistance. So EMF upon resistance is the current, right? So 16 upon 8 is 2. 2 is the answer, right? Yeah. Now let's solve last question of this class, right? 1 or 2 questions, I guess we can do more, right? Okay. थोड़ा question और करते हैं, कोई problem? Let's solve 1 or 2 questions more, right? Okay. All right. करा जाए? Okay. Look at this question. A small square loop of wire of side L is placed inside a large square loop of wire of side L. The loops are coplanar, their centers coincide. The value of mutual inductance of the system is this. What is the value of X? This is what you have to figure out. ठीक है? Value of X आपको निकालनी है. You have to talk about what will be the value of X in this situation. Right? Okay. What will be the value of X in this situation? So B, C, and D. So options are 150, 180, 128, 138. This question will take some time. Try to solve it. So what is happening really? A small square loop is placed inside a large square loop like this. This is a large square loop of side capital L, and a small square loop of side small l is placed inside it. So clearly the magnetic field produced by the larger one is linked with the magnetic field of the smaller one, right? The loops are coplanar and their centers coincide. The value of mutual inductance of the system is this. What will be that, right? What will be the value of mutual inductance? All right, so let's see how many kids are giving the correct answer. Okay, everybody gave the correct answer. Surya was the first one, then Shreyanshi, then we have the Sanya, and then we have the Kanva. So this kid, Kanavan, whatever your real name is, he is from the beginning of the class and giving the answers regularly. Some of them are not correct, but most of them are correct, right? Which is great. Okay. So 128 is the answer. Now let me give you some logic behind it. So you know that in the mutual induction, there is one coil and there is another coil. Magnetic field is produced in the primary coil. It is linked to the current is flowing in the primary coil. It is linked with the magnetic field of the primary coil, links with the secondary coil, and we define a ratio in this situation. That ratio is M, right? So that is nothing but M is equals to phi by I, right? So clearly this ratio is there. M is equals to phi by I, or the flux linkage is M into I. Phi is equals to M into I, right? So in this situation, whatever magnetic field is produced, let's say by this one, is going to be linked with the inner one, right? So we have to find the m in that particular case. Now here we have we don't have exact formula of magnetic field produced by a rectangular coil, but we can get the value of magnetic field by the straight current carrying conductor of length L and then multiply by 4, because if this is carrying a current in this direction, you see that all the arms are carrying the same magnetic field at the center, right? So all of that is going to be added up. So magnetic field due to one of this arm, you see that this is 45, this is 45, right? So magnetic field at due to one arm, we can calculate mu naught upon 4 pi I by r sin phi 1 plus sin phi 2, right? And then multiply that by 4, you can get the total value of magnetic field that is being produced, right? And once you know the value of magnetic field, you can easily calculate further things, right? Okay. So once you know the value of magnetic field which is produced, the smaller loop is placed in that magnetic field, right? Okay. Phi is equals to magnetic field into area. Okay. Flux is magnetic field into area, B into A. And magnetic field we have calculated because of all four arms outside. Multiply that by area. What is area? L square. So this is the flux associated with a smaller part, right? Phi is B into A, right? So this is what we are going to do. This is flux is B into A, L square, right? This is L. So area of this thing is L square, right? What is the flux associated with it? Magnetic field is B produced by the outer one into the area L square. This is the flux associated, right? How much magnetic field is there? Magnetic field produced by one arm is mu naught upon 4 pi I by r. What is r? R is from here to here. The total length is L. It is going to be L by 2. This part is L by 2, right? So mu naught upon 4 pi I by r sin theta 1 plus sin theta 2, right, into L square. This is the flux associated with the inner arm, right? This is phi, right? Divide the phi by I, okay? And you can get the value of coefficient of mutual inductions or mutual inductance M, right? That comes out to be root 128 and power minus 7. And they were giving in the question the value is root x to the power minus 7. So from here x is 128. I believe the idea is very, very clear, right? Okay. Yes. All right. So let's solve one more question, right? And this is the last question of this class, right? This is the last question of this class. Okay, after that, whatever questions I have added, just do that as a homework, right? Few more questions are remaining. Let's say 5-10 questions are remaining. So do that as a homework, right? Do that. Right. Will you do that? Right. So just try to have a look at this question, and after that, few 5-10 questions are remaining, and I'll give you that as a homework, right? So I believe similar kind of sessions if we keep on doing. So you see that how much practice we can do in 4-5 hours. If you were not doing this, you would be doing nothing. But you, in this way, you got to revise so many concepts, right? Okay. Right. So over here, look at this thing. Two coils have mutual inductance 0.002 Henry. Okay. The current changes in the first coil according to the relation, this one. Okay. The first coil, primary coil, is changing the current. So the magnetic field will change and the everything else will change. Where I naught is 5 and omega is this. The maximum value of EMF in the secondary coil is this. Okay. Due to the change in the current of the primary coil, flux passing through the secondary one will change. And since the flux passing through the secondary is changing, an EMF will be induced, right? So we have to talk about what will be the value of EMF induced is this pi upon alpha. What is the value of alpha? So we have to calculate the EMF and compare the EMF with this pi upon alpha, get the value of alpha. Options are given, right? Options are given to you that alpha is 5, 8, 2, 6. Try and solve it. All right. Try and solve it. Great. So the concepts I have just told you, the similar kind of concepts will be applicable over here, right? What is the flux? Flux is simply B into A or M into I, right? They are giving you the value of m. So yeah, and what they are also giving you the value of I, which is I naught sine omega t, right? The maximum value of EMF. EMF created in the secondary coil is due to the change of uh, flux associated with it, which is dependent on the current change through it. So EMF in the case of mutual inductance is m di by dt, right? EMF in the case of this thing is m di by dt, and if you just do that, you can easily solve it. So let's see how many kids are giving the correct answer. So yeah, some kids are giving the correct answer as well. And on those kids, these 5 kids have answered it first of all. Shreyanshi, Saina, Ananya, Kanwan, Surya. These kids are giving the answer correctly and quickly. So how to do it? So as you said, as you have seen it, that the value of flux is mi, which is mi sine omega t. No problem with that. EMF is m di by dt, which is this. The value of mutual inductance is this 0.002. Di by dt will be this, right? The value of current is I naught sine omega t. Differentiate it, so omega will come out. It will become I naught omega sine cos omega t. Differentiation of sine omega t is cos omega t. So this is the value of EMF, right? Okay. Right. So EMF maximum, for EMF to be maximum, cos omega t has to be 1, right? And for that, omega t has to be 0, right? So for maximum EMF, it will be 0.002 I naught omega, this, right? Just put the values over here. Omega is 50 into 2 pi, 50 into pi, right? And all of those things will come out. EMF, maximum value of EMF will be pi by 2 volt. In the question, the value was pi by alpha volt. So by comparison, alpha is nothing but 2, right? So this is pretty much everything, right? That we had to discuss about this class, right? There were so many things we could have discussed, and there are so many things that we will be discussing in upcoming classes, right? If you have any particular requirements as such, right, you can definitely do that in the comment section. If any particular thing is something that is bothering you and you want a live class on that, you can definitely put that in the comment section. I hope solving this level of problem, right, helped you a lot. I don't know how to show the final leaderboard. Can we show it? All right. Is this? Okay. So this is the final leaderboard. All right. Number 1 kid is Shreyanshi. And then we have, I guess, is Sania. And then we have Kanwan. These are the 3 top kids. Also, there is Ananya, Suhani. You see that almost you attempted 50 questions, right? Almost you have attempted 50 questions. You see, right? And Shreyanshi was the fastest one, and then all these kids were there as well, and they have also on an average attempted 50 questions. So you see, in this way you could revise, right? And you could also solve, you could utilize this time, right? Okay. All right. I believe the idea is very, very clear. Okay. So that's it, right? Let's keep the session till here only. I'll see you there in the next class. Till then, take care and bye-bye.